And with this, I would like to say that I value your expertise, support, and commitment put into this event. And together with my organizing and the scientific committee team, I take this opportunity to invite you to this very conference that is expected to produce a Web of Science indexed collection in special issues that have been allocated to the journals that we put in our conference website.
It provides the opportunity to share and discuss the results of the research done with you. For the research institutions and universities present here, a warm call to also become part of the VLIR US community and to submit proposals to us. So I hope you will have an interesting conference.
So the next sponsor is Nawiri Foundation. And while he's coming, please, Grumeti Fund, get ready.
Good morning all. Guests of honor and all delegates and all invited guests, protocol observed. Nawiri Foundation is a non-profit organization which focuses on solving people's problems and youth and women into the societies and communities around the national parks in Tanzania. And main work where we are based at the moment, it is in southern Tanzania. And while talking about southern Tanzania, we are talking about Great Ruaha and also Great Selu. So we are focusing on the communities and societies around those national parks, so to empower and improve their livelihood into their communities, and so the wildlife conservation is observed and is manageable. So as a foundation, we started in southern Tanzania, but also why we are sponsoring this event of Nelson Mandela is because we are looking for the solution of having the same match of what we are doing in southern Tanzania. And we are hereby saying that we congratulate the Nelson Mandela University by having this event and this innovation to make sure the societies around us where we are living, it is improved, but also observing the wildlife, but also our normal living capacities on what we have to make sure our areas where we live, wildlife and aquatic animals are observed. So by saying so, because we are also looking for opportunities to make sure everyone is responsible to this, but also we are looking for the responsible travel companies, those are responsible to the wildlife and conservation programs, so that we can engage with them and also to partner with them to make sure people's life, wildlife also are observed and maintained into the areas. So we congratulate again for the Nelson Mandela to have this session and event, and making sure for you it is the first time, but thinking of that next year you might have a good one, and maybe you involve a lot of stakeholders, tour companies and other companies, those that can be involved on wildlife sustainability and peoples alike. Thank you for listening.
Thank you very much, representative from Nawiri. Grumeti Fund, while he is coming, Wise Future, representative from Wise Future, please get ready. Can you wave if you're around? Wise Future? Yes. Get ready after.
Honorable guest of honor, Professor Riziki Shemdoe, Permanent Secretary, Ministry of Livestock and Fisheries, the Nelson Mandela African Institution of Science and Technology leadership and staff here present, conference presenters and participants, invited guests, conference organizing committee, ladies and gentlemen, a very good morning to you all. My name is Nm-Aist, Government Funds General Manager for Research, Political Monitoring, and Community Outreach. I'm very glad to be standing here today to participate in this important event, which will be discussing very relevant issues in our world today. The Gourmet Fund is a non-profit conservation and community organization, a non-profit organization registered as a trust that works closely with the Tanzanian government, particularly our conservation agencies like TAWA and other key stakeholders and local governments and communities in Bunda and Serengeti districts, Mara region. We focus on conservation management, anti-poaching, as well as applied research for issues and topics that are relevant for communities living in the western area of the Serengeti ecosystem. As most of you are aware, sustainability is a truly interdisciplinary phenomenon and issue. For our communities, industry, countries, and planet Earth to become and remain more sustainable, it is imperative for all who, in one way or another, depend on nature, and that is indeed all of us, to continue doing what is necessary to ensure that the sustainability that we're talking about becomes more of a way of life. And in this regard, I would like to congratulate the Nelson Mandela African Institution of Science and Technology for bringing all of us here this week to deliberate and then network for a more sustainable society. The themes to be deliberated here are very relevant and befitting of your university's motto that says academia for society and industry. I hope, therefore, that as more people learn about this conference in the future, more and more sectors, environmental managers, and policy planners will be participating to enhance the rate, but also the scale with which these deliberations and learnings are used to meaningfully transform our societies for better, especially in this day and era where climate change and resource challenges continue to negatively affect the lives of many millions of people. Where we live and work in Western Serengeti, this impact manifests in diverse ways, such as food insecurity and reliable farming seasonality, invasive alien plant spread, and various forms of land degradation, to mention but a few. The Gourmet Fund, through our purpose-designed research and innovation for the Serengeti ecosystem program, called the RISE for short, will be happy to explore ways to enhance collaboration with the Nelson Mandela African Institution of Science and Technology and other like-minded parties in promoting an interdisciplinary approach to sustainability. I once again congratulate you and thank you for your kind attention. Thank you.
Representative from CRDB. And once they will be around, I will give them a space to say something. Thank you.
Honorable Professor Riziki Shemdoe, Permanent Secretary, Minister of Livestock and Fisheries, Professor Anthony Mshadete, Acting Vice Chancellor, Nelson Mandela Institute, Professor Lilian Pasape, Acting Deputy Vice Chancellor, Planning and Finance Administration, distinguished guests, ladies and gentlemen, all protocol observed. Habari za asubuhi. Thank you for having us here. It's an immense honor to stand before you today at the International Conference Tropical Horizon 2024. This gathering with the theme Tropical Horizons, Advancing Sustainability in Agriculture, Environment and Technology, resonate deeply with our core value at CRDB Bank. Over the years, our collaboration with the Nelson Mandela African Institute of Science and Technology has made our highest expectations. Through your unwavering support, professionalism, and commitment, we have managed to achieve a remarkable milestone together. Your expertise and dedication have been instrumental in driving our mutual success. Ladies and gentlemen, at CRDB Bank, we believe in the power of tripartite mantra, people, planet, and profit. This mantra guides our every action, decisions, and strategy. We recognize that our true sustainability in achieving only when we consider the well-being of our people, the health of our planet, and the economic viability of our endeavors. Our commitment to the people of Tanzania is unquestionable. As the leading financier in the agriculture sector, with 60% of agricultural loans in the country coming from our bank, we are proud to support the backbone of our nation. To us, agriculture is not just a sector, it is the lifeblood of our communities. And 65% of our people are employed in the agriculture sector. As a bank, we are dedicated to empowering farmers, providing them with the tools, resources, and financial support they need to thrive. Those familiar with our history know that CRDB Bank is the bank of farmers, particularly agricultural cooperative unions. Agricultural financing has always been at the heart of our business. We have an intimate understanding of what works and what doesn't in this critical sector. However, farming methods and techniques that were effective a decade ago are no longer sufficient. The landscape has changed dramatically, influenced by climate change, technological advancement, and evolving market dynamics. We recognize these shifts and are committed of helping farmers adapt resilient practices that enhance productivity while safeguarding the environment, ensuring their continued success and sustainability. Ladies and gentlemen, our effort in sustainability financing earns an accreditation from the United Nations Green Climate Fund, in short form GCF, in 2019. This accreditation was the stepping stone of our $200 million Tanzania Agriculture Climate Adaptation Development Program, in short form TACA-TDP, that targets to benefit 4 million smallholders directly and more than 6 million people indirectly by 2030. As the leading bank, we believe that the technology plays a pivotal role in advancing sustainability in agriculture and beyond. Through TACA-TDP, we champion the use of technology to drive sustainable farming practice, from precision farming techniques that optimize resource use of digital platforms that provide farmers with the vital information and access to the market. We are harnessing the power of innovation to create a more sustainable future. Our quest of sustainability financing does not end here. Last year, we took a monumental step forward by issuing Tanzania's first green bond, named as Kijani Bond. This Kijani Bond was oversubscribed by 429.6% and underscores our commitment to promote a sustainable economy. The funds raised are channeled through toward financing projects that enhance sustainable agriculture, energy efficiency, reduce carbon emission, and support sustainable development. Ladies and gentlemen, our commitment to the planet extends beyond our financial products. We have integrated environmental, social, and governance, in short form ESG, system in our operations since 2013. Our sustainability strategy aligns with our business goal, focusing on decarbonizing our portfolio and promoting sustainable operations. This year, our head office building in Dar es Salaam received international certification as a green building. If walking the talk were a bank, it would be CRDB Bank. But our journey towards sustainability is not one we undertake alone. We collaborate with our customers such as the Nelson Mandela African Institute of Science and Technology and various partners to incorporate sustainability, environmental, social, and governance in everything we do. This partnership promotes our climate action, equitable community nurturing, high quality care, and social livelihood for all genders and marginalized groups. Lastly, may I take this opportunity to extend our gratitude to the Minister of Education in Tanzania and all institutions under ministry in a special way. I would like to thank Nelson Mandela Institute of Science and Technology in Arusha for giving us the chance to participate in this conference. As we gather here at this conference, I want to assure you of CRDB's bank commitment to leading by example in championing sustainability in agriculture, environment, and technology. Together, we can create a brighter and more sustainable future for all. Asanteni sana. Thank you for listening. I wish you fruitful deliberation.
Asante sana. Makofi mengi kwa sponsors who made it possible. Ladies and gentlemen, dear participants, now I will welcome Professor Anthony Mshandete, who is the acting VC today, to give, he will have two roles to perform. Number one is to give a remark as the acting VC, but number two, as the final role, he will invite the guest of honor to give his speech. Professor Mshandete, please, the floor is yours.
Very good morning all. Professor Shemdoe, Permanent Secretary, Minister of Livestock and Fisheries in the United Republic of Tanzania. Professor Lilian Pasapi, Acting DVC for Planning, Finance and Administration. Professor Jao, one of the local organizing in the project of BRID. Professor Munish, who is currently also the BRID program coordinator at our institution. Professor Karen, who is the representative of the coordinating institutions in Belgium, Flemish and Tanzanian partner universities, deans, directors, distinguished guests, media representatives, ladies and gentlemen, good morning. I feel honored to stand here today to welcome you all to the International Scientific Conference with the theme, Advancing Sustainability in Agriculture, Natural Resources, Environment, and Technology. I am thankful for your presence here today, despite your busy schedules. Distinguished guests and ladies and gentlemen, I extend my appreciation to our guest of honor, Professor Rezik Shemdoe, for blessing us with his presence momentous occasion. I would like also to thank all our esteemed partners from Nm-Aist, which was represented by Madam Mabe, Nawiri Foundation, which was represented by Nm-Aist, Epimac, Rumek Fund, which was represented by Mr. Mbise, SADB Bank, which was represented by Madam Susan Shuma. Wise Futures, I didn't see them here, but I know they are around. And other collaborating universities, KU Leuven, University of Brussels, the University of Antwerp, Mwenge Catholic University, I have seen them here, and the University of Hasselt. Your unwavering support and the collaboration have been instrumental in achieving the milestone we are celebrating today. Dear ladies and gentlemen and participants, as we proceed with the conference, I encourage you, each of you, to engage fully in the discussions, share your experiences, share your competencies, and build professional networks. Together, let us explore the boundless possibilities that the conference unfolds. May this conference inspire you with transformative ideas and pave the way for future collaborations and also engagements, where we save humanity in Africa and also beyond Africa. Dear participants, ladies and gentlemen, without any further ado, I would like to welcome Professor Shandoe, our guest of honor, to address the audience and officially opening our conference. Thank you so much for listening.
I have officially opened this workshop before I forget. Professor Anton Mshandete, Acting VC Nelson Mandela, Professor Linus Munish, VRIL Program Coordinator, Professor Lilian Pasepe, Acting DVC, PFA, Professor Njau, Professor Karen, Flemish and Tanzania partner universities, deans and directors of schools, conference delegates, distinguished guests, media representatives, ladies and gentlemen, habari ya asubuhi, good morning, hoi, hoi. Let me start by saying this. I'm standing in front of you, being very happy this morning. Why? Because I'm part of the real beneficiaries. And I've been called to officiate this conference, and I say, yes, I think this is now, I'm going to
my alumni status. I got some funding in, under the South House Initiative in 2014, 2016, where I carried a project that is called Developing Effective Strategies to Engage Private Sector and Civil Society in Reducing Emission from Forest Degradation. So I carried that program, and one of the papers that made me to be associate professor came from this program. So I'm standing in front of you very happy and thanking really for supporting not only this conference, not only this program, but also supporting me to reach the level that I have reached. Thank you very much. It is my pleasure to be here and profound appreciation that I stand before you, acknowledging the presence of each one of you, despite your busy schedules. Thank you for gracing this event with your presence. It wouldn't have been an event if you guys were not in this room. So I'm not taking this for granted. I'm grateful that you have made your time and come to attend this important conference. For our guests and all of you who are new to Arusha, I am pleased to inform you that you are at the heart of Africa. Very close by the beginning of humankind, the old vine God, as famously named the cradle of mankind. Please take time to enjoy your time in Arusha. We have a number of touristic attractions in this part of the world. So you might decide to go to Manyara, you might decide to go to Ngorongoro, you might decide to go to Serengeti, you might also decide to climb Mount Kilimanjaro. So I'm inviting you that before you leave, make sure that at least you spend half a day or a day to enjoy the touristic attractions that we have in this part of the world. Distinguished participants, ladies and gentlemen, I'm indeed honored to be invited to officiate the opening ceremony of this conference with the theme on advancing sustainability in agriculture, natural resources, environment, and technology. It is expected that at least 200 participants will come to this conference. And when I was seated there, I started counting. So when it reached 150, I said I'm no longer counting because 200 will always be there. I'm grateful that you decided to hold the first Nm-Aist 2024 International Scientific Conference at the Nelson Mandela African Institution of Science and Technology, which among others will showcase research results, innovations, and institutional collaborations with academia, scientists, researchers, development partners, and other stakeholders. I'm expecting that you have invited also policymakers so that what you will discuss here, they can use it in policy decisions. And if you have not done that, you are here for 3 days, please, the last day, ensure that you invite them so that they can read and hear the communique of the meeting that you will come out with. Distinguished participants, ladies and gentlemen, on behalf of the government of Tanzania and the Nelson Mandela management, I wish to extend my heartfelt gratitude to presence of, what is the name? Nawiri Foundation, GRUNET, as well as CRDB. Thank you for coming. Thank you for facilitating the organization of this meeting. Distinguished participants, collaborations at the university level with development partners is highly welcome, especially in applied research, aiming at solving problems. It is important that we do research that can solve problems. So seeing you here, I'm hoping that the results that will be presented here, research findings that will be presented here, are those ones that will address communities' problems. So we are looking forward as the government to use the recommendations that will be coming from this conference in decision making. And it's important that in every endeavor that research is involved, it will be good that we invite policymakers so that they can use the research results in their decision making. Colleagues, I note with satisfaction that this conference will be the very first international conference on tropical horizons for our institutions in Tanzania. I'm very grateful to the Nelson Mandela and the collaborating partners for choosing this to be the founding horizon on the scientific engagement around this that is expected to generate new horizons in the future. I commend all players in this first horizon for successful launching and implementing this conference with overreaching theme, as I said, tropical horizons, advancing sustainability in agriculture, environment, and technology. Distinguished participants, I'm glad to learn that this conference has been organized in such a way that there will be discussions, experience sharing, and reflections on advancing sustainability in agriculture, environment, and technology. You will also discuss on the role of emerging technologies in promoting innovation and sustainable and market-driven green industrialization in sub-Saharan Africa. These discussions are timely and relevant for charting out strategies and the strategic directions that African countries should take in attempting to prepare critical mass of youth with required and relevant skills in line with the national, continental, and global frameworks. In Tanzania, we are now endeavoring to prepare our vision, 25 years vision, and that is 2026, 2050. I'm looking forward to have some contributions from this conference. Whatever will be discussed, let us assure ourselves that we come with even a single statement that can go into that vision. That should be the aim at the end of this meeting in the 3 days to come. I'm hoping that I will also have that copy and see how I can also take it further to the respective teams that are preparing that document. Colleagues, let me underscore here that the role of science and technology, as well as innovation, can play in promoting technological innovations and industrialization in Africa cannot be overemphasized. It is even harder to imagine how have we reached the present stage of development as African nations, or how we can make further progress in intensifying agricultural production and agricultural production systems and sustain green economy without taking deliberate measures to increase investment in science, technology, and innovation. So the facilitation that has been given by VRIRI, it has to be acknowledged, because we are trying now to intensify by increasing investments in science, technology, and innovation. So as a government, we are appreciating that support that you guys have given Nelson Mandela to carry out the research, but also to ensure that people are coming to share what they have been doing all over the time. Colleagues, before I conclude my speech, may I also take this opportunity to call for higher learning institutions and research and development in Tanzania and Africa at large to continue to undertake applied research, provide innovative solutions for problems in our local context, in cities as well as in rural areas, with ultimate goal of promoting socioeconomic transformation. Certainly, technology and innovation-driven economy will help to enhance the competitiveness of Africa and drive sustainable economic growth and development. For this to be realized, participation of all stakeholders, that is the government, industry, academia, research, and informal sector is inevitable. To collaborate and co-create technological solutions for economic development. Let's take a moment to celebrate our collaborative engagement, as well as realize these achievements and anticipate future opportunities for collaboration and continued growth. You can even see, I mentioned that I benefited from VRIRI grant almost 10 years ago when I was at the university. And by the way, I did my PhD at Ghent University in Belgium. So I'm also part of that country. 10 years down the road, I'm standing here again, officiating the VRIRI-funded program. I'm underlining this because of the collaboration that I'm calling upon. This should not be the end. I'm requesting all scientists who are seated here, please write proposals, write collaborative proposals, write collaborative projects so that we can have our problems sorted out by using research finding, technology, and innovation. In conclusion, on behalf of the government of the United Republic of Tanzania, I would like to express my sincere appreciation to all the partners, conference delegates, faculty, staff, and students who have contributed to success of this conference. Your dedication and hard work are the foundation of achievements realized so far. I encourage you to keep working together, inspiring each other, and striving for excellence in all your future endeavors. With these few remarks, whether few or not, I now declare the first Nm-Aist International Conference with the theme Tropical Horizons, Advancing Sustainability in Agriculture, Environment and Technology officially opened, and I wish you successful deliberations. Asanteni sana, merci, bedankt.
Makofi mengi kwa Profesa Ndoe. Asante sana Profesa. That was Professor Rizk Ndoe, Permanent Secretary, Minister of Livestock and Fisheries. He has already declared it's open. Allow me now to bring Professor Lilian Masato will be speaking for the DVC PFA and give the vote of thanks to the guest of honor. Thank you.
Honorable guest of honor, our esteemed participants, all protocol observed, good morning. First of all, I would like to take this opportunity to thank our Almighty God for the gift of life and bringing us all together here. On a special way, we are very grateful for the presence of Professor Ndoe with us today, our Permanent Secretary, Minister of Livestock and Fisheries. I know that he's very busy and he has a lot of responsibilities at the central government, but we appreciate your commitment to support science, and remember that you are also once and will always be the researcher and the academician. We are very grateful for your speech, and we have taken a number of issues, especially on the issues of applied research. We are working on that. Also, what comes of this deliberation to be part of our contribution in the Vision 2050, and this is a big opportunity for us to contribute to that area. But also, we have accepted the issue of having the policymakers in our conference. We have a number of policymakers around, but we'll ensure that even at the local government level, we have a representative. We are very grateful for the sponsors, and on behalf of Nelson Mandela management, we are very grateful for VRIL. VRIL have been our first collaborative project.
We, as I mentioned earlier, we were expecting to have the representative from Ngorongoro Conservation Area Authority, but they are not here yet. So we appreciate them and we recognize their contribution to this event. We also have a representative from Wise Future, and I'm informed that they are around now. So allow me to welcome the representative from the Wise Future project to give us a sponsor's remark, just in a few seconds or if not minutes. After that, we'll go for group photo, which will be done immediately here. Thank you.
Permanent Secretary, Minister of Livestock and Fishery, Professor Nm-Aist, Acting Vice Chancellor, Professor Lilian Masato, Acting Deputy Vice Chancellor, Planning and Financing and Administration, Professor Caroline Njau, Professor Lilian C. Munishi, Chairperson of the Organizing Committee, distinguished guests, esteemed colleagues, and participants, ladies and gentlemen, good morning. It's my great pleasure and honor to represent Wise Future Center at this 2024 International Conference on Tropical Horizontal, where we gathered to advance sustainability in agriculture, environment, and technology. Today we are here to discuss innovate, and collaborate on critical issues that shape our futures, particularly in context of tropical regions. The Wise Future Center, establishing a mission of contributing to transform Africa's economy, in dedicated to assemble the crucial mass and high-skilled professionals in the field of water, sanitation, and energy. It's our goal. Our goal is to not just to educate, but empower those professionals to drive cutting-edge research and innovation that address the unique challenges of our continent. Our work is driven by understanding that sustainability development in agriculture, environment, and technology is interlinking with the efficient management of water resources, improving sanitation system, and sustainability energy solutions. Those are the pillars upon which we can build resilient and prosperity community. At Wise Futures, we are committed in advancing interdisciplinary research that bring together expertise from various fields to solve complex problems. Engaging with local communities, governments, and international bodies to ensure that our research and innovations are in the real world impact. Today, we are sharing the knowledge and experience. We must remember that our collective efforts can lead to transformative changes. I'm confident that the discussion and collaboration that will take place during the conference will pave the way for new ideas, partnerships, and solutions that will contribute to development of sustainable agriculture of our tropic regions and beyond. Thank you for your dedication, your innovation, and your commitment to creating a better future. Let us work together to make sustainability not just an aspiration, but reality. Thank you.
Asante sana na poleni na majukumu. Dear participants, it's now time for group photo, and I'll be giving, we'll have it here, so I'll be mentioning some groups to feature in the photos. So labda tuanze na watu wa media mwe tayari. Tuanze na meza kuu kama ilivyo, tupate picha nzuri hapo, alafu nitaita group la, I'll call the sponsors forward. Sponsors, get ready. Something. Sponsors, please. We have sponsors from Vril, UOS. All together, please. We also have Nawini Foundation, Ngorongoro Conservation Area Authority, Roommate Fund, CRDB Bank, Wise Futures as well. project staff. Can we have the Belgian group? Thank you. Don't go far away, because I will call you back after the next group. Real staff project from Nm-Aist. Hawa huwa hawana haraka, wanatembea kitakatifu kidogo, wanatembea wakihurumia ardhi. Asante sana. Naomba mbaki. Now we can have the group combined, Belgian group and Tanzanian group. No? Kuna watu wako nje, real staff. Naomba tushiriki kwenye picha. Mr. Marco, nisaidie kuwa steward. One more is coming. Joyce Rugangila. Joyce, please come. Joyce? Yes. Asante sana. The speakers, keynote speakers, please. Invited speakers present. Invited speakers. Paper presentation speakers. speakers, you remain behind. I have keynote speakers and invited speakers. Oh. Oh, who? What's the name? Luke. Please join. Ah, all right. This is the group of people who will be provoking our mind today. Yeah. Asante sana. So, invited speakers. Thank you very much. Yeah. Invited speakers and paper presentation speakers. This seems magical. This is too big. We will have two groups then. Like 2 rounds. Kuanzia hapo wametosha sasa. Wanatosha? Professor Gomera, kama umekasirika. Asante sana. Next group. This side. Yeah. Please. Right. Sogea tena kidogo. Kama mna tupunguze. Just kidogo. Huku kidogo. Thank you. Then smile. Some of you are not smiling. Thank you. You wait, I think you will come next. What do you think? They join? Okay, come. Double line. 1. Organizing Committee. Organizing Committee. Ni itieni walioko nje pia. Conference Organizing Committee. Naomba walioko nje pia Organizing Committee wa join for group photo. Hii ndio timu ya ushindi. And guess what? I'm among them. One more group. We have 10 speakers who will be speaking on banana only. Banana is also grown in the northern zone, Arusha and Kilimanjaro. So it's a very important group. These are the guys who will be telling us how to, the sustainability of agriculture in banana. Yeah. I thought they would be coming with the ripe bananas in their hands, but falling. So I think we are done with the group photos. Professor, what do you think? We still have any other group? Professor Njau? Yeah,
Maybe there are some people who are just attending to this.
Those who have not taken any photo. Please stand up. Other participants, not in the groups I have just mentioned. Oh, we also have policy makers. I'm told we have COSTECH members here. Can you wave? Oh, join us, please. Oh, you want to go? Okay, you can remain behind. COSTECH, you remain behind. I'll call you. Asante sana. COSTECH. COSTECH ni wadau wakubwa sana na ni watu muhimu kwenye conference hii. Asante sana. Poleni na kazi. kwa sababu hata kukaa ni kazi vile vile. Sasa we have 2 more events coming. The first one, we will have interview. The media people would like to have an interview with the guest of honor. And I'm not sure if they will use both languages or anybody. That's it. And I think they will have it outside. Yes, outside. But immediately after the interview, we have a very important session. It's called health break and networking. And this will be happening just behind this artificial, just behind this hall. Nadhani sasa ni waruhusu mgeni rasmi na meza kubwa tumsindikize kwa ajili ya interview. Makofi mengi tena. Asante sana. You can stretch yourself now, and there will be coffee behind this place. And tea break is not ready yet. We wait after the interview.
Yes. Hello, hello, hello. Hah? Iya Pak nih, Napatikana hewani mnasikia sauti, nasikia kabisa YouTube mnasikia. Yes. No. Sawa, ongeza mbele. Sauti. Bado ipo. Sauti. Okay.
Start germinating. And they're very happy. So it's a pioneering plant and we want to make it permanent. That's the challenge. The second thing is to say, well, in the forest I'm happy. Why am I happy in the forest? There's a lot of litter on the ground. High fertility. The surrounding trees give a lot of high humidity and give shade. And what are we doing in farming, like the commercial sector? We take them under full light. We don't have organic matter. And then we say, oh, we have a problem. So basically, I'm saying we have to learn from where they belong in nature and translate this. And that's what I'm going to use. Okay, so the banana will germinate. How it's happening here are the seeds, if you want to see that. And for those who are interested, it's a monocot. It germinates just like a maize plant. But what we see is that when you have litter, the plants which are pioneering plants, horizontal root system, not deep, not like a tree, explore the topsoil. And we need to do whatever it takes to grow the plants and protect those roots. And those roots are very superficial, about half a meter deep. And here you see also the one on the way top. So, what we need to do when we're going and that's something we see for the next speakers. We need something on the soil. Litter, mulch, manure, whatever you can call it. We need half shades. My colleague Didas, I'm making the case for you already. You need a high relative humidity around your plants. So irrigation just enough is not good, it needs to be in the air as well. We need high levels of nutrients, whatever form. And then it has to be well aerated soil. And it can be combined. All right, so let's go now into the different farming systems. issue. These are volcanic soils, nutrition is washed down, and what you're having on top and below is completely different. And for example, on top, you have a lot of organic matter with cool temperature, decomposition is slow. Aha, interesting for the soil. The lower side is more hot, decomposition goes faster, and so on and so on. It means that people are adapting to this kind of situations, whether they like it or not. So here we have the upzone, a picture about the upzone, and then we go straight to the banana, and I will not discuss all the details, but you see there the bananas are there, and you see the combination with some fruit crops. We go to the mid-zone, where people are combining it already with some trees. Under the canopy, you find more coffee. And some fruit crops. And then you go to the lower zone, where everything is dry, and where there's a link to the roads, and things turn into cash crops. That means people are moving into monoculture of tomatoes, of your cabbages, of your bananas. It means they're moving into monoculture banana. And for example, this is the Cavendish, the Malindi, which is going into the brewing factory. So the bananas on top, where people cannot be reached properly, are the fruit crops in the up and the mid. And that's the Mshari and some Matoke. And you go down, they shift to the Cavendish. And without going to all those tables, but this table just simply shows for up on the left, mid in the middle, and low, you see each time different words. The banana-based systems are different where you are. But I want to give you as an example, the Mshari is loft on the top. It's fusarium susceptible, right? But it's not a big issue. And now people migrating to the lower side because there is space. There's space. So they say, I'm growing, I love my banana, I bring Mshari to the lower space. It's fusarium susceptible, not an issue. But then they start irrigating, and the fusarium is a soil-borne disease, and to the irrigation water, suddenly I'm having a problem, because irrigation is needed, but it carries your spores of your fusarium. And they want to do monoculture because of cash cropping, and that means you're wiping out your bananas. So they're forced to move into another banana variety, which is the Cavendish. Okay, so let's now quickly go through that one. The top is rain-fed with fruit crops and Mshari. Here it is. The middle one, you have the perennials with cash crop of coffee and Mshari and already the Cavendish coming in. And you go lower, starting to the irrigation, and you must change into another banana variety. If you work with the local varieties, really can make a difference. Now I come to the next point. Clean planting material. People start moving and they carry plants. That's why we have people here on pathology in banana, and they say, if you keep on using your planting material like suckers, we have them here, you're carrying already your problem. Is that a problem? So you need to have it clear. And that's why, okay, you can see the small plants coming from tissue culture plants, and by the way, Marie Chantal, that's a picture from Burundi. So where people are now multiplying in tissue culture work, like it's happening here in Arusha with CBS and Mazuri in Moshi, produce clean planting material. And then you can have good yields. So, I'm coming to the end. What you need for high yields to make impact, understand your farmer, I did not explain that one, but understand your farming system. That means also understand your banana variety, but also what are the situation. So good agronomy, and you will hear a story about good agronomy and organic matter from Akida Meya from this project. Then clean plants, just not, tissue culture is not good enough. I'll leave it there. John Thomas from Australia is here, he will talk about that one. And then Igor, who's on his way. Nematodes have to be free. You can have a tissue culture clean, you have a soil infected, you put them in the nursery, you have again infected plants. And then you need to have improved varieties being developed here. So by the way, here in Nelson Mandela, it's not just an Mshari breeding program, but also a parental breeding program. So Alan Brown will talk about that one. And then we have our supporting team, like Stanley and Happiness, who are talking about the supporting tools for the breeding program. And then, I need to go back to my past love, Nigeria, and the Congo. That means we will talk through Moses about plantain. To finish, in 2021, the Matoke hybrids have been released in Tanzania for a breeding program together with Naro. They are there. You find them out in farmers' fields in the Kagera. And the current challenge, the only challenge we have for the moment, that the demand is higher than we can supply. And we means 2 private companies and 2 public tissue culture labs. And with that one, I'm closing without commenting anything because I give that to the breeder, Alan, that he's already working on the next generation of hybrids. And you see on the left, the old generation, on the new one, the new generation. Thank you so much.
Thank you very much, Professor Swenen, for that keynote speech on bananas. Now we will have to go back and then we hear also the second presentation before we interject with questions and discussions. So our second keynote speaker is Professor. And I take this opportunity to welcome him to the front. But his background is as follows. Will Blake is an interdisciplinary researcher at the University of Plymouth. Is that correct? Plymouth. English is sometimes very strange. He has expertise in environmental diagnostic tools to support sustainable land and water management decisions. As a natural scientist by training, he works closely with social scientists and design thinkers to deliver evidence into action research programs. Approaching sustainable environmental management through a nature-based solution lens, his current work focuses on catalyzing community-led climate-smart agriculture in the degraded agro-pastoral land of East Africa, whole system approaches to reducing soil erosion and siltation of hydropower dams in Latin America, and the application of novel sensor technology to evaluate soils, organic carbon, and soil health in the UK and overseas. He is a friend of Nelson Mandela. He has worked with some people, including Will Linus, in some projects. And Professor, I welcome you now to deliver your speech. Please welcome.
Thank you. Thank you very much for the introduction. Thank you also to the organising committee for inviting me. I really appreciate the invitation. My plan today is to check in on my timing because for a prior speaker I have to be careful to stick to time. So what I'd like to talk to you about today is to summarise almost 10 years of research and collaboration with colleagues at Nm-Aist around the soil erosion aspect of land degradation. It's a project that's had a lot of impact at the local scale. And what we're really keen to do next is to think about how we can translate our learning to widen and broaden out the impact that we've had through the methodologies that we've developed. And so during that process, I started to pay a little bit of attention to the intergovernmental concept of land degradation neutrality, and to think about how that sort of top-down concept that would be driving, I think, a lot of policy change as we move forward. How the learning from community level work that we've undertaken, how that can feed in and how we can bridge those two gaps. So that's kind of what I want to explore today. It's sort of along the journey of our collaboration over the last 9 years with colleagues at Nm-Aist. So I thought I'd begin just thinking a bit about the land change to increase food production, work by Borrellietta. And we can see there are certainly hotspots in the globe, Sub-Saharan Africa, Latin America, Southeast Asia, where there's particularly potentially acute problems in terms of soil erosion challenges. We have climate change represents quite an interesting water rights, changes in rainfall patterns, changes in rainfall intensity, which of course augment the challenge of soil erosion by water keeping those land degradation. And then work by STEF as how the top rights, part of the work, the great acceleration work that they do, where we see all sorts of different impacts across the amount of domesticated land over time. The transition of lands that's been brought into production has actually tailed off compared to all other impacts by humanity on the planet. And that really reflects the fact that we're running out of space to convert. And so it presents the challenge that we're potentially putting ourselves into more vulnerable landscapes to produce food, but also that means to make more of what we have. We need to produce more from the land that we have, whilst preserving and trying to enhance the integrity of the natural capital. So when I think about these challenges and think about the Sustainable Development Goals, I find this diagram by the Stockholm Environment Institute really helpful. So it reimagines the Sustainable Development Goals in terms of the fundamental sort of base upon which we can build and achieve those targets. And what it does is it puts the biosphere at the bottom of the absolute foundation stone of the societal and economic challenges that we face as well. So we have to really preserve our natural capital in order to achieve the Sustainable Development Goals. And for us, that's about enhancing soil health, reducing land degradation, and where we can, reversing what's happened over the last few decades. So the land degradation neutrality concept is something I've only really been paying attention to myself fairly recently. It's certainly rising up the agenda in intergovernmental conversations and policy development. And essentially, for those who aren't familiar with this, it's really thinking about a state where the amount and quality of land resources necessary to support both ecosystem function and food security remains stable or either remain stable or increase. Now, this is then defined as being within a specific temporal and spatial scale. It's different management units in different contexts. But for me, it's quite an important, quite an important concept for us to pay attention to, because the work that we're doing, the work that I'll explain to you, that we've done together with colleagues at Nm-Aist, is really about just that. It's about stabilising the land and trying to regenerate it whilst producing food and working closely with local communities to achieve that. So when I think about the land degradation neutrality concept and what we've done at the community scale, this audience, and then we'll dive into the details of our project and then reflect back upon how we can maybe close some of these gaps. So the first challenge for me is the concept of specific spatial and temporal scales. We often find there's quite a disconnect between what happens on the ground at a community level and where changes can really be implemented in collaboration with communities, and the scale at which top-down action is required from the policymakers. So trying to close that gap and disconnect between the two, I think, is really important. Secondly, the concept as a policy instrument is very data-hungry. Assessment is a really key part of delivering within this framework. And so, how do we build robust data sets that are really relevant to both the communities but also to the policy instruments? How can those data be used to inform decision making? How can they target funding to kickstart transformation of lands? And also funding for monitoring and evaluation as well afterwards. So there's sort of this data-hungry need, this need for information to permit this to really operate. And the third challenge, that's something we've definitely encountered in our research, and I'll articulate more about this as we move ahead, is thinking about that disconnect between some of the top-down recommendations. We have a very large suite of experience across the globe, and it's very much showcased by the WOCAT database. It's a database hosted by the Food and Agriculture Organisation of Success Stories in terms of sustainable land management. But quite often, strategies that might be imposed from outside and worked elsewhere don't necessarily on the ground is the focus of our work, working with the social scientists. Understanding what works where and why is incredibly important when we translate what's happened successfully elsewhere to other places. So really understanding the connection between the possible and the reality on the ground is another key challenge that we need to face. Project has tried to tackle these challenges, but interestingly, we started this some 9-10 years ago. And so for me, it's really interesting to reflect upon our experiences and what we've learned along the way, working across disciplinary and sectoral boundaries, and think about how that now relates to the current policy demands and challenges. So I want to give you sort of a a whistle-stop tour of the project over the next 20 or so minutes, explain to some of what I think are the key highlights, and then come back to the challenges that we face in terms of trying to scale up and out what we've achieved. So as I said, this is a collaboration with Nm-Aist. A lot of colleagues, you'll see names flashing up on the screen, colleagues who I wish to of course acknowledge. And so it's a big team, and the wider community of Nm-Aist as well. We've engaged a lot with postgraduate students within the university, and we're really privileged to have been part of the Nm-Aist family, the research family, over these last few years. So our research was, well, the main project I'll talk about is sort of a free project in a moment, but it's funded by the Global Challenges Research Fund in Britain. And this is sort of a UK version of the BLEAR programme, probably slightly smaller in scale. It's now come to an end, in fact, so it lasted for some 5 to 10 years in the UK. But it was research money that had been allocated to our research councils within a development context, a capacity building context. We're looking for win-win research strategies that could build capacity on both sides to achieve the sustainable development goals. And also particularly in terms of building capacity on both sides to work across disciplinary boundaries to bring impact. So the research requirements were for impact, and for us that was a really important part of the journey, to be required to deliver impact rather than just delivering evidence. So we started our collaboration back in 2015. So the work was first of all initiated through work that I've done with the Joint Food and Agriculture Organisation and International Atomic Energy Programme on nuclear techniques in food and agriculture. So it's very much a technically driven research agenda, and it's very much about how we can use nuclear isotopic tools to support food and water security. So different methodologies for tracking and tracing sediment, soil and nutrients in the environment. So I've been a close part of that, and I guess at this point in my career I was very much focused on the technical aspects. I was very much within my disciplinary silo, thinking about how we can build process knowledge of how soils and sediments move within the landscape. And it was within that programme that a colleague Belgians, another Belgian connection, Professor Pascal Buch, University of Ghent, he and I came together and thought, well, how can we start to translate, how can we get funding to start to translate some of this technology that we've developed with colleagues around the world into places that really need it, for example, some of the degraded lands that we're working with in the local environment here. So we developed this programme, and we had colleagues going across. You can see Prof. Nishi there in our laboratory, and it was very much about learning from each other about how these tools and techniques can be developed. So we learned a lot. So I won't go into the technical detail of what we learned, but through the case studies that we did together, we learned quite a lot about how. So we learned a lot technically about what was going on within our study catchments. But when we came to talk to the local communities about what we found there was a huge disconnect between the knowledge that we developed technically and what was understood by the communities and how that related to their own knowledge. And what we realised was that in order for this work to be impactful, we had to connect much more closely with the community. And for us as natural scientists, coincided very nicely with the new funding streams that were available through the Global Challenges Research Fund to demonstrate how we, as natural scientists, could collaborate across disciplinary boundaries to bring change. So really the narrative that we had in our mind was that the diagnosis of the problem, the quantification, we needed to understand all of the dimensions of the challenge, working with the communities to try and make a difference. So that was sort of the birth of our interdisciplinary evidence interaction framework. So we set that up as a hypothesis to test in our first project. And essentially what we aimed to do was to see how we could combine the natural science tools and techniques that we'd already developed. I'm moving my cursor, you can't see it, but you can see around here, defining the problem hub. But it was very much about fusing the social science methods with the natural science, so we can understand the whole problem, both the human and the natural aspects of the problem. Then thinking about the psychology of decision making, identifying pathways to change. What was making, or what was driving the decisions that were being made that were potentially problematic in terms of the land health? And then working with design thinkers, people who understand problems holistically, who have tools and methodologies to bring ideas together through workshops and participating in practice, how we could work with design thinkers to then really bring all the evidence together from all the different sectors to co-design solutions to the problem. So we presented that as a model to test in this first programme, and that was we chose to work in the Makayuni catchment of one of the sub-catchments of Lake Manyara, and we had 4 or 5 target case study areas in which to work to practice this methodology. So there's a lot of detail within here. We did a lot of quantifications, you can imagine, on both sides. And we built up a pretty good picture of the soil erosion process narrative. From my side of natural science, we learned a lot about the variability in soil erodibility, the different land management practice, differences in soil hydrology. So we had a really good idea of the complexity of the challenge and sort of that whole translation of material along the soil sediment continuum from the denuded landscapes, looking at those root pedestals on the left, right the way down through the sedimentary system and down to the siltation problems downstream and all the ecological aspects of that. So we built a very big quantitative picture about what was happening, which I don't have time to get into today. But the big learning point for me, certainly as a natural scientist, was that generally in my past I thought about some of the drivers of the soil erosion and the land degradation problems as being grazing, overgrazing, land management decisions. But what we realised, of course, through the social science and working with the communities was that those, what I consider to be drivers, were in fact symptoms of much wider problems, wider pressures that were driving decision making. And so we learned that actually the overgrazing aspect was a symptom rather than a direct cause. And the wider issues, of course, population growth, changing rainfall patterns, social cultural change within the communities, particularly in terms of sedentarisation, changes in governance and shifts in land ownership. So there are lots more things going on that were pushing communities into making problematic decisions that wouldn't necessarily be the first choice, but through necessity of survival, these decisions were being made, and the consequences were seen within the natural environment. So for me, that's a big learning point, thinking about the system holistically. So thinking about the patterns in space and time, what we wanted to do next was to think about where how the land had got to the state it was. What was the temporal context of the challenges that we were witnessing on the ground? So my PhD student Martin Weiners, working with colleagues here, did a lot of work on sedimentary archives of change within the systems. And essentially what we're trying to do is to find sediment sink zones within the landscape, places where sediment's accumulating in response to upslope soil erosion. We're drilling down into those, as you can see in the photographs, taking drilling cores, taking those cores of sediment back to the laboratory, slicing them up. And each slice of sediment that's been accumulating through time tells us some kind of or carries some kind of a record of change within that catchment. And we interrogate that using our nuclear tools, isotopic tools. We can use radioisotopes to date the sediment to work out how quickly it's been accumulating. And we can use the geochemistry to work out a little bit about where it's come from in terms of both process and source. And just to give you one example here, this case here, which is a sort of a mid-catchment lake basin that we drilled, we did a fairly complex multivariate analysis of the geochemistry of the samples, and it's been summarised in this factor plot here, which essentially is showing us, we can see the direction of the arrows within that diagram. That's showing us a journey from back in time, the lower parts of the core, the oldest parts of the sediment, up until the present day, at the time the samples were taken. Moving from the right to the left of the diagram, the geochemistry is telling us about those sedimentation processes within the lake. On the right-hand side, the chemistry is dominated by processes of sediment formation within the lake. On the left-hand side, it's the trifle inputs of soil from the catchment. And so the sediment core is taking us in a sequence from a period of less erosion to a period of more erosion in the present day. So it's certainly showing us that there's been an acceleration of material moved across the landscape. And then the movement up and down on the y-axis, the chemistry there is telling us about translation from less wet materials, subsoil materials, into more wet material, topsoil. And so what we can see on that journey from a time of less erosion to a time of more soil erosion is a transition from, I guess, historic subsoil gullies and stream bank erosion to a period of intense topsoil erosion, which then was followed by a period of incision, gully erosion to the present day, where we have gullies that are pumping large amounts of sediment across through the system. So that was over the last 20 to 30 years. So there'd been some switch within the landscape that had led to this very widespread degradation. When we compare that to satellite imagery, so you see at the top, we can see that what we see from the sedimentary records coheres with what we get from the remote sensing. And when we spoke to the local people, it coheres with their time frames as well. So we understood that the current situation was something that was relatively new in decadal timescales. Next, we want to think a little bit about how things translated in terms of connectivity in space. So we've got very much an insight into the time frame of the challenges that we face within the landscape. We next want to think about how do things connect in space, because this would provide some kind of a blueprint, a template for interventions to take place within the study communities. So to get an insight into what's happening, we undertook some very detailed drone surveys of our study communities, and this is one case in particular. And what was happening here was that grazing lands, which you can see to the left-hand side of the diagram towards the lake, the grazing lands there were severely degraded, but the water that was causing that problem had been supplied in part from upslope land that had been converted into cultivation. And so we wanted to get a sense of where and how the water was flowing across that landscape to provide some kind of an understanding, a connectivity understanding of the landscape, which can be used as a blueprint for intervention. But what we discovered during the process of this investigation was really quite interesting, because there are two areas of terraced land upslope that geographically had the same risk of soil erosion, and land management practice at first glance looked to be very similar in terms of slow-forming terraces. But what we can see, and you can possibly see it if you look carefully at the diagram in the upper slot, the B zone, which is the zone to the right, there was very, very intense rill erosion. So micro gullies were cutting across the terraces. The water was being fed very actively from that cultivated land across the terrace boundaries and into the downstream gullies, causing all sorts of problems. Whereas in the zone D, which is in the bottom left, we had what looked like exactly the same landscape, but there was no rilling. There was no water crossing over the boundaries. And so we had two areas that were essentially geographically at the same level of risk, but one was much more active in terms of erosion than the other. So it was then through our social science and talking to the communities about practice that it revealed that in fact the area that was not eroding had been set up under supervision of expert extension workers. The area to the east on that diagram, to the right hand side, had been set up a little bit later, where the communities observed what happened in the other place and they replicated. But they hadn't interconnected a little bit on the technical details. And so the terraces lacked a little bit in terms of the boundaries, there's a little bit less planting, and the soil management practice also was much more prone to overland flow. And so then by connecting those communities together within a workshop, allowing peer-to-peer exchange of knowledge, the community that was suffering from the erosion problems could actually make some very small adjustments to what was going on within their landscape. And that was supported by infographics that we produced in terms of how the hydrological processes worked. And then the community were able to set up a new environment committee to undertake more planting and to implement subtle shifts in how they manage the soil. All in response to understanding from their neighbours in terms of what was different between the two landscapes. So again, it was that the evidence, the knowledge within the community was kind of unlocked by the research that we undertook to try and understand a little bit more about how the land was connected in terms of people and the upstream and the downstream. So I just wanted to say a little bit more, this is not my own expertise, but just the sort of closing points of that last example really exemplifies the importance of the researchers and the community working together, but also the community working together as well. And so my social science colleagues, Claire Kelly and Mona Nazeri, are really experts in this, and they really focus on this idea of closing the gaps, to understanding both the human and the natural factors that are causing the problem, but also then thinking about how can the community then be lifted outside of this challenge. This is looking at community resilience theory, where some kind of a disruption, in this case it's the soil erosion, has led to a drop in community resilience. And it's about finding the right pathway out, co-designing that pathway, providing the evidence, and developing the evidence with the community to help decide the best pathway out of this challenge. So what my colleagues do is they undertake some quite complex analysis of conversations that they have with the community, interviews, structured focus groups, and workshop discussions. And this analysis of the text, in the same way I play with geochemistry data and analyse it in a multivariate way, they work with text and ideas and concepts. And they undertake this what they call a complexity analysis. And they look at the linkages between all the different concepts and challenges that the community face, different ideas, and from that, through the methodologies that they use, emerge potential interventions, things that potentially will work within that community. For example, develop skills and knowledge, training, restoring the lands, empowering women, strategic conservation agriculture in places that matter, thinking about those flow pathways, changing livestock practice, new bylaws that will help communities manage common land. So those ideas emerged, and then it's a very carefully choreographed, this is the design thinking part, very carefully choreographed visioning exercise, where the communities were invited to think about the future that they might like to see within their landscape, and to think about the present, and these are the two slides of the diagram. You see it below, you can see it in practice there. Prof. Minishi there is orchestrating a visioning discussion there, and the community then feed in ideas as to what the different steps would be back from the future that they would like to see, and then back to the present day. And that allows then interventions to be mapped out, it allows a blueprint and a timeline of change to be laid out. That's owned by the community and informed by the research. It's a very effective process, and for me as a natural scientist to witness that, I find it really inspiring. So what we're seeing in these communities, and these are of course these sub-communities at community scale, so testing and developing practice here. What we see is a lot of change, and a lot of change, this is another example, I mentioned already the planting and the environment communities and transitions on the ground, new bylaws, grazing, exclosures, keeping cattle off land to let it recover. All of these things have happened as a result of the workshops. And in this case, this is working with the Lead Foundation, developing water harvesting techniques on the ground, which of course slow the water down to prevent erosion from happening, but also allow more water to penetrate into the ground and allow the seed bank that's remaining to recover. So all of these activities are taking place, but these have been driven by the community. There's no external funding to fund these, there's no capital investment. These are things that have happened from within the community as a result of the mutual learning between the researchers and the community. So they're driven from within. So in terms of how we scale out and how we move forward and thinking particularly about that evidence-based aspect, this is 9 years research with 3 communities, and we've learned a lot, but how can we translate what we've learned now into that broader picture? And I think one of the big challenges for us is that evidence base, how do we gather evidence more rapidly and more spatially extensively. And so this new area that I'm moving into is using soil scanner technology, and I just want to give you very briefly, just to close, some examples of how this is working. So quite often when we're looking at soil organic carbon, one of the key measures that we saw on the first few slides about land degradation neutrality assessment, measuring soil organic carbon is time-consuming. Samples will be collected and need to go to the lab. This is near-infrared spectroscopy, some of you may be familiar with the technology, but it's an instrument that essentially shines near-infrared light into the soil and measures the spectral response, and if that's calibrated correctly with the right algorithms, it can give you an estimate of soil organic carbon on the ground directly within the field. So we trialled this with local communities as a citizen science engagement tool. We built up very good ideas of the variability within organic carbon within their landscapes. But what we found most effective about that is the communities engaged with the data collection process and they co-own the data. And so that idea of data ownership, people well trained, you can build very, very large databases for these landscapes with appropriately trained local people and the right equipment. And that's just a sample methodology. I think a lot of people are familiar with that. What's new on the horizon is gamma spectrometry, portable gamma spectrometry, which we're experimenting with now in the same landscapes. And essentially what this detector does, this passive detector does, is you can see the local farmer here walking with this detector, is it's measuring natural radioactivity coming out of the ground from the minerals of the soil. And that signal is perturbed by the amount of organic matter and moisture within the soil. And so you can see this calibration curve in the bottom part of the diagram there. So the greater the signal, the less organic matter and moisture in the soil, the lower signal, the greater. And what we've done is we've just trialled this as a technique for building up very large-scale evidence bases from farm to community scale. And the results we have are really, really quite promising. So this is data we collected just last year, which we presented at the European Geosciences Union this year. And what we can see, if you look at the colour schemes within those tracks, and the tracks you can see on the diagram there, essentially where we've walked with the local farmers to different areas of interest, areas where the community felt it would be worthy of trying to get a better idea about the soil health. And what we can see is that the brightest colours in the left there are from the severely degraded gully land, where we're getting a very strong signal out of the ground, because there's nothing really in the soil other than the minerals to reflect that signal. When we go to the opposite extreme, where Linus is standing there on the right in a conservation agricultural plot. The signal is suppressed, the darker colours are shown getting less signal, very high organic matter and moisture. Now the really exciting thing about the data, you can see there's a spectrum of variability there, but within the diagram, just to the right of the bright spot, I can't show you with my mouse, but you can see there's a sort of a line through the diagram there, which is the road. Now, to the left-hand side of that road, the land was put into special exclusion measures. Cattle were excluded for some years. On the other side is the distribution in terms of grazing. And what we can see with the detector is that the colours to the left, where the cattle have been excluded, is about 3 years. And you can see in the photograph below the greener area. The detector is picking up a significant difference in radioactivity counts. So the gamma spectrometry appears to be a sensitive tool for mapping land degradation. We think there's a lot of value here. It's not just about the data, it's about the community engagement, because here we're just using colour. So we're not even quantifying, we're just using colour to allow the community to see the differences within the land. And you can imagine how a map like that could then allow communities to make sensible decisions about where they might want to remove cattle, or where they might feel the land has a little bit more to give in terms of community resilience. So that's where I'm here. Yeah, I'm at my end. Yeah, thank you. I'm just keeping a PDR on the time as well. So that's really the conclusions from me. There's a lot of text here, but I think for me it's about that fusion of local environmental knowledge with the research knowledge, and really unlocks the capability for a community to make its own decisions and to drive that bottom-up change. And the solutions are often within the community that need to be unlocked. It's that collaborative work across sectors, but also including the policymakers within that process, allows things to be aligned. We certainly need capital investment. I think allowing communities to understand, there's a lot of work to be done on the agri-economic side to really help communities understand why undertaking change in practice will bring the benefits that will bring down the line. But I think certainly we need external capital investment in many places to kickstart that change. And so I think for us, there's a responsibility to communicate the success stories that we have to intergovernmental bodies, to really try to influence donor contributions to kickstarting change, but always working with the community so that we have sustainability in that practice. And finally, I think it's just this movement into rapid assessment tools, the data hungriness of current policy is really important. So I think how we can work to make sure those rapid data acquisition tools can be used effectively to close that data gap is certainly an area that I want to spend time. Thank you very much.
Thank you very much. Can we clap for Okay, so I welcome you to sit here at the front. And also welcome Professor Shannon to kindly come to the front so that we can have dinner discussion. Okay, we have about 10 minutes to discuss what has been presented from the two speakers. And I welcome the audience to ask questions or propose something as far as the two presentations are concerned. So who is going to start the questioning? Okay. Yes, so please, I have one hand there, please.
Can we see the hands and then we keep your hands up?
I start with the gentleman there. Please.
Can I have extra microphone?
Thank you very much. My name is Yogi Karwani. I'm an agronomist. Thank you, Professor Ron, for good presentation. I like much on how you do your work and initiatives. I have a few questions as well as recommendations as far as the agronomy on banana concerned. The first one you showed us how the banana has been cultivated in different levels, especially the high, mid, and the low. And you mentioned that due to the climate change and the soil, you find that there are soil erosions, especially in the upper, and you find that the banana which has been cultivated, it is quite different from the lower. And the lower you mentioned about Cavendish. And as what I know, the Cavendish is a higher feeder. It requires much of water as you compare with Matoke or the Eastern Banana Islands. So to me, I was thinking about how can you come up with varieties actually which can be on a root system, which can tolerate about the water or can use the water effectively rather than going to Cavendish, which require much of water, and it has been suited in the lower part of soil katana. Another issue is about especially on the use of mulching for soil organic amendment. I was thinking about when you look on the Kilimanjaro where we are here, the Kilimanjaro landscape, we have no the grasses which we can use as much. And when you look on Kagera, we had what we call the banana farming systems, and we had three. The Rueya, Kibanja, where we find banana, and also the lower part. And they used the Rueya to get the grasses to make as much. But nowadays, there are some shift to planting the exotic trees, the pine and whatever, and they are no longer getting the grass to match the fields. And that also becomes a problem as an agronomy to make this banana to use effectively of organic. As we know, and you mentioned that most of the root system of banana is require the upper, which is with the topsoil, rather than the deep soil. So I would think that we should think about how we can have the system which can support this system as far as climate change concerned. Thank you.
I wonder whether we should not also get the secondary questionnaire so that we can tackle it. Professor Lu?
Thank you very much. My question was mainly addressing the fantastic presentation by Bill. So thanks for that. So as an aquatic scientist, I was not aware about the land degradation neutrality concept. So in the beginning of your talk, I had the impression it was mainly a quantitative concept, like the soil erosion. But towards the end, I got the impression that also qualitative aspects are considered, like soil humidity, carbon content. So my question is this already integrated in the soil neutrality, soil degradation neutrality concept? And is also the soil biodiversity and the functioning of the soil ecosystem taken into consideration?
Thank you very much, Professor Lu. Was there another question? Yes, please.
Thank you, Professor Roni. I commend the good work you have done with your trip. I comment is that I'm passionate about Uchare, and I'm looking forward to it the next generation. I recorded the number of studies that will come out from your team. But there's a good amount of banana knowledge produced, and that is continuing to be produced. But we see on the ground there is a gap between local farmers' knowledge and especially on the decision and the indicators they use to decide on the patterns of banana-based system in the field. I mean, combination of trees and even the type of tree that they put on the farm. I wonder if this came into your knowledge in the process of your research, and if you can comment on any success story on that. Thank you, Prof. Blake. The spectrometer detectors on solid carbon or on carbon, how deep could that detect? Does it detect only on the surface, or it also detects in the profile? Ronnie, the catena you indicated, I agree. You acknowledge that organic carbon is very important, and it really is very important. But also probably the mineralogical composition of the soil, especially on these volcanic mountains. You have maybe high concentration of anorganic material on the upper zone, maybe less on the middle zone where we have native soils as dominant soils. And again, in the plain, you have more fluvial, but of course, you like vegetation on the lower slopes. So, if you may wish also to comment on that. Thank you so much.
Thank you very much. Now we hear some reactions because we are running out of time. Okay, one more person to ask. Thank you for asking questions.
Good morning. My name is Anita Rubenga. I have one question for Professor. I have 3 varieties of bananas, the matoke, the plantain, and the malindi. So in different lines, the line with matoke has yellow leaves, but the rest are healthy and green. My question is, if that is the disease, could it pass across the rest of the varieties? Thank you.
So let us now, let's now hear from, we start with Professor Strain.
What I will do is try to summarize each question to come to the main points, and I hope that I do that correctly, and then I discuss the possible answer. So the first question was dealing basically along the transect. We have a difference in the weather. I won't say climate change, but in the weather. And then that means basically at the lower level we have lower rainfall, and that's why we are having Cavendish, so-called to be a heavy feeder. And I think the question was basically, do we have a replacement for this heavy feeder? If that is a correct interpretation of your question, then I need to say the following then. It's also market-driven. It's not only biology. The people want Cavendish for different purposes. It's a cash crop, and this is not happening with so much with the other crops. So if we would go for a replacement, let's try for a replacement. We go for M-Shire, the current M-Shire. Basically, it is as heavy feeder as Cavendish. It is the same thing. Even genetically, it's very close. But if you bring it to the lowlands, you must irrigate your whatever banana. And it's through the irrigation that you bring in the disease, the Fusarium disease, and you simply kill your M-Shire very quickly. What can we then use for replacement? We could use matoke. Matoke is resistant to the disease, but matoke cannot support the high temperatures on the leaves. Matoke must be under cool conditions, even for the canopy. So in a nutshell, M-Shire is not an option, matoke is not an option. Then we could go for all kinds of strange varieties, and I won't have the time, but here at IT and Nelson Mandela we have the collection. and we can discuss possible alternatives. I think Sucari and Daisy, again, not an alternative, because Sucari and Daisy will grow in the lowlands, but you must irrigate, and your fusarium is over. So, that brings me to this presentation of Alan Brown, who has some possible solution, I'm shy. Let's wait for his talk. I did not mention the farming systems of the banana-based farming system of the Caldera. I can only support what you're saying about the importance of the Ruea, so the grazing, the different types of grass which are growing there, which are being used either for the house or the patching or for the mulching of the banana plant in the Kibanja. What I need to add to the whole story is the following. It's not only about organic matter when you talk about mulch. It's not only about organic matter. The grasses are bringing in different nutrients, and banana is a silicon accumulator. It's one of the important plants like rice, a silicon accumulator. So the gramineae are extremely important. So when you replace an organic matter with something else which is not high in silicon, we're in trouble. What can I recommend for the moment? Nothing. I don't know what to say. I know when people start turning the Ruea into farmlands, the basic if that stops, the whole system starts collapsing. Quite simple. But in Kagera, the middle belt, so if you talk about, you have Bukoba, Muleba, Beramuru, and on the other, in the west you have Ngara and you have Kotelbon. But in the middle you have rangelands. That rangeland is full of manure. You just are overwhelmed by the amounts of deposits of manure. So if you lose your Ruea, use more manure from the middle part. That's what I would recommend. Okay, then there was a question of Professor Didas. How to inform farmers. I think I would like to refer to the upcoming speaker of Akida Meas. There's one way of informing is saying, I'm going to the farms. But the other way is simply do your research with the farmers. Like Professor Willem Blake is doing. Do it on their farms. It's the best way to have them to buy in and to teach you as well. Because they're also experts. And that's what he has been doing. We had several on-farm trials with different organic matter, fertilizer combinations, so he will explain about that one. And long story short, the results were so spectacular that he was invited to give his talks in the churches. Because he was there, they could see it. They say they come to the campus, first of all, they don't see it, but if they see it, they don't see there are any tricks, because it's happening there, in front of their eyes, day after day. So on-farm research is the key. It's difficult for scientists to publish, by the way, and I think I admire what you're doing, but that's the best way to get there. Then about the transect about the nutrients. I think Karen van Kampenhout is the expert to talk about that one, but my colleagues of the Nm-Aist IP1, Roel Max, he can tell you about all those stories. So basically, it's not about erosion we talk about the nutrient flow from the highlands to from the upper zone to the mid to the lower zone. And basically, as you said correctly, in the lower zone, in the high zone we have more organic matter, the lower zone is lower. But the nutrient flow, especially of, what do I say, of potassium and sodium. And we are getting into sodium toxicity in the lowlands. There's simply too much sodium, so the one charges, the nutrients are there in too high concentrations. So we're getting, in fact, too much of the good things. So that's an issue. Then I would like to come to Anna. Anna, your question about plantain and matoke and Cavendish, it's difficult if I don't see it. Yellow can be nitrogen deficiency. And then you could say, is it a soil reason? Or when you will hear from Danny Coyne and Happiness, could it be a nematode reason? And of course, then maybe you have enough nitrogen, but the roots are being damaged. I cannot give you the answer. What it is, I need to see the pictures. That maybe during coffee break you can show me, because it's not. It can be many different reasons. It can surprise me. I cannot give you the answer, and I think that's also what happens in research. We do not know all the answers.
Okay, thank you for the questions. I think I'll start with the question about the land degradation, neutrality, quantification, the assessment side. It's a really important point. You know, there's one soil metric in the equation, soil organic carbon, and it's making big assumptions about the correlation between that and other benefits, in particular the health of the soil in terms of the microbiome. And we know there's different types of carbon, there's different relationships with soil health, different relationships with nutrients and fertility and so on. And so it's kind of I guess it's a necessary generalization for a policy instrument that's intended to be used to scale. And it's the quantification side is there to support decision making in terms of resource allocation at national government scale. And so it's necessarily simplistic in that regard, and I can understand how and why it's come to be that way. But as a researcher, I agree with you that it doesn't tell us the whole story, and there is risk of, I guess, particularly if it's then being used as a tool for resource allocation, there's a risk of resource going in the wrong direction. So I guess there's a responsibility for us in the research community to test those assumptions. Certainly the literature that I've seen in terms of how that assessment tool will be used to allocate funding needs to take a closer look at those assumptions. So I think for us there's quite an important research pathway to test that in different contexts. There's a parallel in the UK, the latest government policy on land management payments to farmers is called the Sustainable Farming Incentive, where farmers are given a payment to undertake practice that offers to improve soil health over the long term. And the key measurement there is soil organic carbon again. Again, based on the same assumptions. And so what we're actually doing in the UK context is testing that assumption. So I'm working with ecologists looking at the microbiome alongside the basic measurements. I think we intuitively know that a healthy soil is going to have good organic carbon, organic matter content, but we really need to test that in different soil types. So I agree with you. I think there's some work for us to do there to test that. The other thing alongside, which sort of takes us a little bit into the sensor technology side, I guess the challenge again is the quantity of data that can be collected and the risk that if that's the metric that's chosen, how representative are the samples that go into it. And again, I think for us, the sensor technology offers that opportunity to really upscale the quantity of data we get, but it's testing and making sure the protocols of the sensor deployment are appropriate to deliver data that we can trust. So I think we're always going to be benchmarking back to the lab, but certainly on the soil microbiome side, there are new sensor technologies now which are exploring how we can assess very rapidly in the field, for example, bacterial fungi ratios, which can again be very indicative of soil health alongside the carbon measurement. So I think there's also a lot of value there. We're doing this in the UK, but not yet out here, to integrate those sensor technologies. But I think the fundamental thing is, the question is, can we rely on the sensor technology and the data that it provides? That brings me nicely into the other question about the spectrometry in terms of what it's actually measuring. So the physics of the gamma spectrometry essentially depends on quite how high above the soil your passive sensor is mounted. The height that we deploy it at the moment is in backpacks, which is about just under a metre, about 0.8 of a metre high. In theory, is giving us something like 95% of the signals. It's all based on probability statistics of signal release and attenuation. As you can imagine, as you get near the surface, you really get a great probability of signal from the surface being captured by the detector. But at about a height of 0.8 metres, theoretically, it's the top 30 centimetres of the soil, which for most protocols in carbon assessment is the depth at which you sample. But again, we need to experiment with that in different soil types. And the other point you made, which I think was very, very pertinent, because the colours I showed you, the trial data that we have on here is very bright colours, where we have a very low organic matter area because it's been severely denuded. We're creating water in the mineral soil. But those are less weathered soil substrates, and that less weathered soil substrate might well contain a greater part of the parent material providing the signal. And so we may have some kind of accentuation of the signal because of the weathering profile. And that's something that we need to test. In fact, there's a shipment of samples that's just arrived in Plymouth from Nm-Aist for me to put through our X-ray fluorescence to exactly test that hypothesis that we proposed. So I think you're right about the, for us and the centres offer a huge amount of opportunity to close data gaps and to engage the community. But we have to get the protocol right so that we can really trust what we get from the detectors. We can all pick up the detector, walk out in the landscape and collect data right now. But what the data actually means is another matter. I think the research has to be done very carefully, very transparently, and everything that we're going to do is we'll be open source so everyone can see exactly what the signal is being translated into. I think that's the kind of practice that I'm hoping the centre community will follow, so that there's complete transparency to what we're measuring.
Okay, thank you very much, Professor Sven and Professor Blake. We are now coming to the end of this discussion because the time is really out of the mark. But I thank you very much for the presentations and discussions. Thank you.
That was the first round of keynote speeches, and it was led by Professor Njau. In the next few minutes, we will also have a series. This is another round of presentations, and this will be led by Professor Didas Kimal. Professor Didas Kimal, please. Professor Didas Kimal will lead us through until we go for lunch break, and I would want to insist that he observe time. Let us please spend no more than 15 minutes in your presentations. Yeah, you can operate from where you are. So thank you.
Good afternoon. Yes, as you said, my name is Professor Didas Kimal. I'm a professor at Mwenge Catholic University in Moshi, chairing sitting on the desk of the Deputy Vice Chancellor of Planning, Finance and Administration, but also I'm coordinating research in that. You in this session, and we have here 6 presentations, and as our MC put it, is that each presenter will be given 15 minutes, and after 2 presentations we shall have a few minutes discussion. So our first presentation in this session will be presented by Alan Brown. Alan, please. And it is about 9 years of banana breeding at Nelson Mandela African Institution of Tropical Agriculture. Brown, the floor is yours.
Habari za asubuhi. My team is always laughing at me because Kiswahili, Jango.
Please have your microphone switched on. Yes, there we go.
So I've been the senior breeder here at Nelson Mandela for the past 9 years, and I think this is a very timely and the accomplishment. Year here at Nelson Mandela, so this is a good opportunity to see things forward. First of all, it's important to note that this has been a collaboration between Nelson Mandela, IITA, TARI, collaboration that's been going on for about 9 or 10, almost 10 years now. And the funding has come through the Bill and Melinda Gates as part of breeding banana for small-scale farmers in the Great Lakes regions. For those who are not from this area, the difference between the Chadi and the Toki is essentially based on texture and flavor. They're very different. Sorry for the technical problems here. The differences between the Chadi and the Toki is based on texture and flavor, and it's there's an important cultural element. So Machadi is very important to the northern region of Tanzania, particularly the Chaga, the Meru, and the Pari, while Matoki tends to be more to the western and the Kagera region. Our breeding efforts here have focused exclusively on Machadi. So the program here began in 2015, essentially clearing the lands, digging the holes, establishing the plantations, developing the plants, and now at 2024, we are now a fully mature, fully operational banana breeding program. And I would go so far as to say that we are now the most efficient, most modernized banana breeding program in Africa. My Ugandan colleagues may disagree with me on that, but so a timeline of this, in 2016, was the establishment of the pollination blocks at Nelson Mandela. Through 2018 and 21 is producing the first Machadi hybrids. In 2020, developing the product profile, that is essentially the roadmap for what we want to breed for. In 2022, developing and evaluating the first Machadi hybrids that had resistance to Fusarium, was turned over to Tari and Toski for evaluations at multi-locational trials, and we anticipate the release of this material in next year. So we have one cycle worth of data, and we need a second cycle to release them. The establishment of the infrastructure. So we had prepared 12 hectares of land at Nelson Mandela. Boreholes had been drilled, drip irrigation installed, 4,000 plants went through the tissue culture lab, fenced and protected against disease, and some of this land has been provided, of course, to Nelson Mandela students for their research project. I'm looking for Akita. I know he used part of our land for his PhD. There are 3 operational labs at Nelson Mandela: tissue culture, pathology, and molecular biology. And these labs are not just used by IITA, they're also used by students at Nelson Mandela for their projects. So we've had more than 100 students go through and do part or most of their research in our laboratories. It's a marriage between research and education. I want to particularly commend my staff. I have 12 IITA technicians at Nelson Mandela. More than half of them have either received their master's degree or their PhD from Nelson Mandela, or they're in the process of doing this. So it's a question of not just developing a research project, but taking advantage of the educational resources that are here at this university and training the next generation of researchers. A list of some of the students that have either received their degree, currently receiving their degree, or starting their degrees. So this is more than half of my staff. Banana breeding is challenging. It's probably the most difficult crop to work with. Just part of it is due to the fact that producing seeds in banana is extremely difficult. If I can pollinate a bunch for 6 days, I'm lucky if I get 2 seeds out of that bunch. So it's a very slow process. Bananas also flower year-round, which is great for food security because you always have a source of bananas. But at the same time, for pollination, that means that we have to be out there 6 days a week, 52 weeks a year doing pollinations. And we have to do evaluations all the time as well. So it's a challenging crop to work with. I've been breeding fruits and vegetables for 30 years, and the other crops don't even come close to the challenges of banana breeding. Even when you produce these seeds, sometimes the seeds are poor quality and you get poor germination. So again, just getting to that stage where you have hybrids that are viable enough to do evaluation is a bit of a challenge. You go to field evaluations. You have to have at least 2 years worth of field evaluations. They go to evaluations for pathology, so they have to be screened for fusarium, for nematodes, for weevils, but they also have to be screened for consumer acceptability. So texture, color, flavor, taste. This involves bringing in a panel of experts, local people, farmers, consumers that are familiar with the product, and getting their feedback as well. And finally, it gets to the stage where it goes to TARI for multi-locational trials and TOSCI for registration and release in Tanzania. So we are at that final stage now with the Machadi program, developing the first banana that were bred entirely within Tanzania. So this will be a big thing next year. The product profile I spoke briefly about. This involves all actors within the chain, the market chain, from consumers, farmers, marketers, everyone who's involved in Machadi bananas, and getting their feedback in on what's the blueprint for the banana that you want. It's got to have the right quality, it's got to have resistance to disease, and it's got to have improved agronomic characteristics. So we go through these evaluations, we identify those individuals that come closest to meeting that profile. But essentially, it comes down to these three components. It's got to have yield that's equal or superior to what is currently being grown. It's got to have disease resistance, and it's got to have quality consumer acceptance. If you're missing one of these three pieces, then it's not going to be successful. So we have now digitalized all our data collection, and we were the first place in Africa to do this. So all of our evaluations, all of our pollinations, all of our data is automatically uploaded to our online system, where I can see exactly how many pollinations have been made. I can track back the pedigree of particular crosses, and all of this is available at a finger, with your smartphone. We are one of the first systems to have drip irrigation installed, so we have year-round availability of water. We can look at the genetic potential of the plant under optimal conditions. Now, once they go to multi-locational trials, they are trialed under the farmer's conditions, and we get feedback there on how they perform under suboptimal conditions. So this is our favorite at the moment. I'm calling it Machadi Kubwa, but that name may change as we move along. TARI may decide for a different name on it. It is resistant to Fusarium race 1 and the TR4. So the TR4 is not in Tanzania at the moment. It's in Mozambique. But if it becomes a problem, we already have an answer for it. Fusarium is the biggest problem in this part of Machadi producing Tanzania, because once it gets into the soil, it's there for 10 years, it's very persistent, it's hard to get rid of, and it's difficult to grow Machadi in that area. It's got a 60% increase in yield. It has a consumer preference score that is very similar to the parent that it came from. And it was developed in 8 years. Now, 8 years sounds like a long time, but to banana breeders, 8 years is actually extremely fast. As comparison, the Tarigan bananas that were released last year took up to 20 years to develop. So we've cut the time in half when it comes to developing the material. Machadi Kubwa. When I came here, I had 3 personal objectives, things that I wanted to accomplish. One was Fusarium-resistant Machadi, and we've done that. 2 is to train the people to take over for me when I retire next year. When I go back to play with my grandkids and I come here on a visit, I want to see the same program progressing in the future. And third is to help develop a center of excellence in Arusha for banana research. This one's been a little slower going along, but I think there's a lot more interest now. People are more enthusiastic as being part of this, and there's no place else in Africa that I think is better suited to have studies on banana research than right here in Arusha. So what comes next? We continue to produce new hybrids. We continue to produce hybrids that have resistance to multiple diseases. We've got Fusarium down. Now we need to think about weevils. We need to think about nematodes. We think of Sigatoka, and increasingly about bunchy top. The other thing that's coming along is we're producing material right now that I think has value as dessert bananas. So that should be our next move from Machadi to dessert bananas, as they are related to one another. Strangely enough, Machadi is one of the parents of Cavendish and Gros Michel. So if we can introduce resistance into Machadi, that makes it so much easier to introduce it into the dessert bananas. We need to improve the way that we're phenotyping quality. So right now, it takes us up to 2 years to have enough material to provide to the consumers to test it and give us feedback on whether it's acceptable or not. I need to know more about the genetics of those traits. What are the genetics of texture? What are the genetics of aroma? What are the genetics of flavor of these bananas? So that we can do this stuff faster. It's really one of the slow points for our breeding program. We are making progress on other diseases. This is a list of some of the hybrids and their resistance to nematodes. So some of the hybrids we're producing are as resistant to nematodes as the parents of the breeding program. We need to incorporate that into the material that we have in Fusarium resistance. Bunchy top is now increasingly becoming a huge problem here. We have one of the leading experts on bunchy top here in the audience. He's going to speak later about this. But we need to start breeding for bunchy top. There is resistance, and it can be incorporated, and hopefully it won't take us 8 years to get to the point where we have something for you. And that's it. I can save you some time.
Thank you so much, Brown. You have served us with the 2 minutes, so you may have a seat.
Okay.
The next presentation is from Massimo. Okay, thank you so much. The floor is yours.
I will share with you some reflection about the issue of living fossil fuel underground in the tropical rainforest of Amazon in Ecuador. And this is the outline. I have 15 minutes. I try to stay inside the 15 minutes. The topic is to focus on the importance of Amazon rainforest, and then to focus on an important event of last year, the referendum in Ecuador, in which people declared to decide to let fossil fuel underground in the Amazon rainforest. Then some consideration of climate justice and the economy of fossil fuel, what we call it as zombie energy, and then some activities from below using geographic information system and geographic information technology in participatory way to advance in this process of changing fossil fuel economy toward a just transition. We know from interesting work of International Panel for Climate Change how tropical rainforests are important for global climate. So we can be egoistic in this approach as people living in different countries. What is the contribution of tropical rainforests in the world? Tropical rainforests of Amazon, of Africa, of Asia. As you can see, the orange color connection, if something changes in Amazon, things can change in the United States, in Eastern Africa, in North Europe, in Asia, etc. Maybe a lot of media spoke about the climate crisis in the Amazon and the drought in the Amazon last year. There is important work of the Commission for Amazon doing a research in the importance of water, and this is what are the scenarios of climate crisis in Amazon rainforest in the next 40 years, especially in terms of reduction of precipitation due to the change of forest cover. There are two processes, deforestation and degradation, and these processes are related to some human activities, but I want to focus in this scheme. This is a representation of the three main forces around the tropical system of Amazon. From one side, the process of development and the colonization frontiers implemented by the different states. From the other side, the dynamics of globalization and the financialization of economy for fossil fuel, for meat, for wood, for some commodities like soya. And from the other side, the action of citizens, what is called the grassroots social movement. In these dynamics, it is possible to shape different horizons for this ecosystem. This is an article we produced some years ago about the oil production in Amazon rainforest. This is the surface of Amazon rainforest covered by oil activities. It is around 10% of Amazon forest ecosystem are concessioned by oil and gas activities. There are 5,000 wells, and the seismic line are 10 times the length of the Earth circumference, Earth equator. This is, for example, the superposition between oil and gas in the Amazon, between protected areas in the indigenous area. And this is in this map you can see where we should live underground oil activities. In this central map, all these activities are superposed to natural protected areas and the indigenous land. What does it mean to make oil extraction in Amazon rainforest? It means a lot of social environmental impact. Here you can see the gas flaring, deforestation of area of production, some change in the landscape, the contamination of oil extraction. These are photos prepared and taken by myself doing the activities. This is contamination again of production water inside the forest. This is an interesting element because you can find a footprint of an animal licking the salt. This means the contamination enters inside the ecosystem structure. This is some abandonment of oil activities, especially the the extraction material. And what happened? The company just put information, please, this is a dangerous place. It is what happened. Okay, in this context, it is very important to consider the contribution of the grassroots movement in Amazon. In the last August of 2023, the citizens of Ecuador were involved in a referendum to declare if they want to leave fossil fuel underground in a protected areas. The result was amazing, considering that in Ecuador to vote in an election is compulsory. If you don't vote, you lose some rights. And to have this result of 959% is very high. Citizens decided to block oil extraction in this area and to restore the area and to move to a different economy. This is the coordination of organization doing this. You can find university professors, indigenous group, farmers, citizens, women movement, and animal movement, etc. It is how the media communicated about all the block of fossil fuel company was against the referendum. And this is very interesting comment. The Ministry of Energy say we cannot live with hair, birds and reptiles. Okay, in sense of the fight for the referendum, something not so interesting. And what is important is at international level in the global governance of climate. Only in 2023 the international governance decided underground for the first time. But before arriving to this official statement, the citizens movement gave an important contribution, especially in Ecuador. The fight to leave fossil fuel underground started in the beginning of the 2003-2004. This is very important because a fossil fuel just transition, the just transition fossil fuel requires involvement of people from below. Why it is important to act through tool of geographic information? This is an example. We have an article. The multiple level of injustice we find in this area of Ecuador in which oil is extracted. Another concept very typical of this kind of analysis is the territory of sacrifice. We sacrifice some territories, some people living in these territories, to extract commodities, foods, but other things, fossil fuel, etc., to put this commodity in a cheap price international market. And this Yasuni, this area of protected area of Ecuador, is a territory of sacrifice. When we think about just fossil fuel transition, we should think about 4 categories of actors. It means all people excluded from affordable energy, all people experiencing the socio-environmental impact of oil extraction, all people living in the sacrifice zone in which energy is produced, etc., and also people working in the fossil fuel energy sector. Normally, when we think about just transition, we think only in workers, but it's not enough. We should think at least in this category of actors to frame a just fossil fuel transition. Justice has many dimensions. I think we can open a very long discussion, but this is not the moment here. Why we should leave fossil fuel underground? This is a big problem because the capacity of atmosphere to welcome again carbon dioxide is 10 times lower than the possible carbon dioxide emitted by fossil fuel industry. It means we are in what we call the zombie energy. this energy can have not space for the future, because this energy is killing us. And the distribution and the logic of to leaving fossil fuel underground should be differentiated. Some countries have to reduce more than other countries the emission, okay, and just fossil fuel transition start from below, from citizens. This is, for example, what happened in Amazon, a bio-regional plan from indigenous group to leave fossil fuel underground, or a campaign, a world campaign, to create a new treaty to re-elect fossil fuel underground. I want just to arrive and to conclude. We are research has an important role to develop in helping and supporting with extreme citizen science the fight of people against fossil fuel for a just transition. This is an example in which we supported a campaign to close a flare in Amazon rainforest, and through this campaign the local tribunal give reason, give a good sentences to farmer and indigenous group, asking for the company to close this fossil fuel activity and this burning activity. This is very important in a way of using technology and the role of scientific activity in supporting this process of just fossil fuel transition. What I can say, we can say this is some example, etc., but we should build space of decarbonization, and especially to see Amazon in different ways. There is one vision of Amazon, the Amazon of limits, and the other vision of Amazon created by citizens, by indigenous group, by farmers. It is the living Amazon. An Amazon in which farmers, citizens, and indigenous group fight a different way of integrating and managing natural resources. And this is the framework. Yes, I have 30 seconds. I use all the time, 30 seconds, and it's very useful, the program, because it gives you the time. There is in Latin America an interesting work. It is called the Eco-Social and the Intercultural Pact of the South. In this Intercultural Pact of the South, we are discussing and creating a very critical vision on the extractivist economy. This is the point of departure. Thanks.
So much. Massimo, can you have a seat? Ah, okay. Yes. And Mr. Brown, please. And FC, let's have one or two questions.
I just had one announcement. Duba Golicha, if you are around, please identify yourself. Duba? No. Thank you.
Okay. Who is? Yes, please. Please.
Please keep your hands up. We want to identify who will be asking.
Yeah, thank you, presenters. Mine goes to Alan. I appreciate. I come from banana growing area. So I saw you were doing multi-site trials of your new varieties. So I also heard the discussion in the morning around different agronomic and farming practices. So I wonder, for example, issues of mixed farming practices were part of the multi-trial experiments that we are doing, so that we know that at least they also embrace some of these practices, especially that are done in our local environments. Thank you.
Yeah, that's a good question. Thank you.
Maybe we hear the other question and then. Oh, yes, please.
Thank you. My name is
Rieli Namuge, and my question goes to Massimo. As a political student, I know there is challenges that we face on promoting a just equitable division of resources within communities. Now, my question is, what are the challenges in linking the spatial data and the socio-economic realities of the indigenous or local communities on the ground? Thank you.
100 millimeters, and they have shallow soil of silt or the silt clay. They have vegetation cover dominated by forest bushland as well as wooded grassland. So for the case of methodology, we had the 4 experimental experiments which were situated 2 in the upper landscape, which is above 1,700 meters above sea level, and the other 2 were located in the altitude below 1,700 meters above sea level. So we had 2 at Monduli and the other 2 at the Arusha district, as you can see in the picture, and they were situated in the. They are settled in the randomized concrete block design with 3 duplications, and the treatments were the combinations of these 2 nature-based solutions. One was the pensetam, because pensetam are the one which were selected for the as a filter strips. So we had pensetam integrated with lab as the regimes, but also we had pensetam integrated with Canvaria. We had pensetam integrated with desmodium. We had a plot with pensetam alone, and the other one we had a local Maasai practice where we did not apply any treatments. So as you can see, these crops were selected based on the, first we focused on the availability on the area, so there are some locally available, but also because most of the Maasai people are livestock keepers, that's why we focus, most of them can also be used as a fodder for their livestock. So the plot had a length of 22.5 meters and a width of 2 meters. And at the end of each plot, we had a collector tank. You can see the blue tanks at the bottom of these experimental sites to collect the sediments as well as to measure the volume of the land of water. So as you can see, this is how the experiments were established. So pensetam were planted 1 season before starting of the data collection. So it was planted in 2021, and it was planted in a line of 5 meters apart in a contour which were established by using A-frame. And the planting of the Canvaria were 60 kilograms per hectare for the seeds. For the lab were 30 kilograms, and the desmodium were 5 kilograms per hectare. It was planted just by drill in a line of 30 centimeters apart. So this is how the treatments looks like after a full establishment. Those 5 treatments, and the last one, the one with the combination of all the treatments. So the data collection, we collected different data, including the rainfall data, the runoff, the sediments from the 2022 to 2023. And the sediments sampling was done daily after every rain occasion, and it was taken at 9 o'clock a.m. by vigorous steering the runoff water in the tank so that they can be well mixed, and then a half a liter were sampled and then taken to the laboratory and trying to get those segments. And then from those segments, we just measure the weight of those segments to get the amount of sediment in 1 liter of water, so that at the end of the day, because we also collect the total volume of water for the whole season. So we get the total volume of water in the season. We use that amount of soil which we have collected in half a liter, get the seasonal soil which is lost through those runoff water. So then the sample were taken to the laboratory for analyzing to see the nutrients which were lost through those runoff. And the soil were analyzed by using FTIR spectral, which is a scanning, but the high-tech from the ECLAF lab in the at Nairobi. And data were analyzed by using GenStat software, and ANOVA were used to test the hypothesis to see how this combination of different plants can improve soil quality or can reduce the soil loss through this runoff. So these are the results, starting with the effect of this legume bean manure cover crop combines with legumes on the runoff. As you can see, for the lower landscape zone, it was observed that the local Maasai practice had a higher runoff water as compared to other treatment, and the lowest were found in the combination of lab and pincetum, as well as for the upper landscape zone, the highest were also found for the local Maasai practice. The highest and the lowest were found in the desmodium as compared to the lower landscape, where the lowest were found on the lab and pincetum. And this is because it was found that lab performed better in the lower landscape than in the upper landscape. So at the lower landscape, they had very well vegetative establishment. They had a very good cover for the soil, so they used the direct physical damage of the raindrops, but also the root systems. They improve the infiltration of the water and reduce the runoff of the water. For the effect of these combinations on the soil loss, also for the lower landscape zone, the highest was also recorded on the Maasai local practices. The highest and the lowest were found in the lab. Same applied for the soil loss in the upper landscape zone. The highest were found in the Maasai local practice, and the lowest were found in the desmodium and pincetum. And the issue is the same reason that these legumes have different ability of adapting to the environment. The desmodium were found to perform better in the upper landscape zone because of they have high amount of rainfall, but also the temperature. So they had well-root establishment, but also the cover, which reduced the direct effect of the raindrops to the soil, and also they also provide the aggregation of these soil particles, so it reduces the detachment due to the runoff water. When it comes to the effect of the napier grass with the legume cover crops on the nutrients also, the highest loss of nutrients were found in the local Maasai practice, and the lowest were found in the lab. The same applied for the upper landscape zone. The highest were found in the local practices, and the lowest were found in the desmodium combined with the pincetum. When it comes to their influence On microfauna abundance, the same case were observed. Desmodium and pensetum were found to have higher abundance in the upper landscape zone, and the lower landscape zone, the lab and pensetum were found to have a higher abundance. And this is because their ability to cover the soil and to drop the leaves on the soil by increased organic matter, they provide food for the microbes, for this microfauna, but also the shelter and the good environment for them to survive. When it comes to species richness, the highest species richness for the lower landscapes were found in the lab and pensetum for the lower landscape, and for the upper landscape were found in the treatment with the desmodium and pensetum. With the glass tube, specifically the pensetum, reduce runoff water, sediments, and nutrients loss. And the the combination of lab and pensetum were found to perform better on the lower landscape zone, and the combination of desmodium and pensetum were found to have better in the upper landscape zone. So by recommendation, we recommend that farmers should harness the natural attribute of these vegetation types, but also the land managers can effectively manage nutrients by using these two nature-based solutions. Thank you so much. This is the end of my presentation.
Okay, thank you. Thank you, Mr. Kalonga, and thank you, audience, for the big applause to Mr. Kalonga. Now I'm calling another presenter, and this is Helena Mieya. Helena Mieya, please.
Helena Mieya is not around, so we bring on board Helen Mapunda.
Okay, Helen Mapunda. Yeah. Please. Yes. You are who? Helen Mapunda, are you around, please? You are Helen Mapunda? Okay. So we have Helen Mapunda, and she is going to present on the impact of Arbuscula mycorrhizal fungi on banana plant growth during nursery management phase and the field establishment. 15 minutes. Yeah, you're welcome. You can start.
Thank you. Good afternoon. I'm Helen Mapunda, a master's student in Nm-Aist of Science and Technology. I'll be presenting to you the research that focus on the effect of a bispora mycorrhiza fungi on promoting banana growth. And this study has been done in two conditions, that is under nursery phase and field condition. Banana production contributes significantly to sustaining food security in Tanzania. As other presenters said before, banana contributes a lot in sustaining the food security, as it is being used by several communities as a staple food. And this crop feeds about 30% of the total Tanzania population. Despite it being very potential, it is facing a number of challenges, such as drought stress, declining in soil fertility, and increase in pest and disease pressure that hinders it achieving its optimal production. Also, lack of readily available green planting material is another factor that hinders most of the small-scale farmers, as most of the farmers use suckers from the already existing farmers from one farm to another. And the use of these suckers tend to be difficult, as if you want to establish large farm, the suckers that you get from one farm, you cannot reach the amount. Or also, the existing suckers can be one source of of transferring the pest and disease from one farm to another. Like any other countries, Tanzania is seeing a significant decline in banana production due to drought and other climate-related issues. So there's a need to promote these challenges, especially drought. So to promote sustainable banana production, there's an urgent need for developing environmental-friendly approaches. In this light, there are several technologies that can be used. So in this light, one such approach is the use of a bispora mycorrhiza fungi for enhancing banana production. Then what are these bispora mycorrhiza fungi? These are natural occurring soil organisms and may be used as biostimulant or biological control agents. These organisms establish a symbiotic relationship with the host plant. They are found in the soil. They are naturally found in the soil. And AMWs are believed to have several effects to the plant, to the host plant, as they tend to increase nutrient uptake, also water uptake, and to reduce plant stress. The researchers showed that the presence of AMF to the plant increased water uptake, as these mycorrhiza have the ability to increase the root biomass. They tend to colonize the root zone of the plant. So they form a small hyphae that are main hyphae which are very thin, and they can easily reach the small particles of the soil or deep down the soil and easily absorb the nutrient and water from the soil to the plant. So it aids when the plant is facing the challenges such as drought or nutrient deficiency. These mycorrhiza help the plant to get enough nutrient or water from it. Also, they have the ability of generating the antioxidants that act as defense. When these mycorrhiza colonize a host plant, they prevent some other pathogen to attack the plant, especially to the root zone of the plant. So, in general, this figure explains the plant stress tolerance, nutrient uptake, increase in nutrient uptake, and soil health. All these together improve the soil stress tolerance, hence increase yield. And the general objective to this study is to understand the contribution of AMF inoculation on enhancing banana growth during nursery phase and the overall fruit yield in field condition. And there are two specific objectives. Number one is to evaluate the performance of selected AMF strains in enhancing banana plant rate growth during nursery phase. And the objective number two is to determine the effects of selected AMF strains and yield under field conditions. This study was conducted in two regions, that is Arusha and Kilimanjaro. These are among the regions that are among the leading producers and users of banana. In objective number one, that is to determine the effect of AMF strain under nursery phase, we used two banana cultivars that were sourced from Maua Mazuri laboratory, and the two cultivars used were Granine and William. The three AMF strains that were sourced from microbiology laboratory in Catholic University of Leuven in Belgium. These strains were Rhizophagus irregularis, Rhizophagus interradicis, and Rhizophagus claris. Also, we had a control where we did not put any strains. Also, we used two media in this study. That was cocoa that was filled in jiffy pallets. Also, the forest soil that was filled in polyethylene bags. And the experimental design under nursery phase was completely randomized design. The inoculation was done during the nursery phase when the plants were ready from the laboratory. The inoculum was placed on top, the hole was made on top of the growing media. Then few pieces of inoculum were placed on the soil. Then the plantlets that were ready from the tissue culture laboratory were placed on it. So the plantlets from the laboratory allowed to grow in the presence of The data collected under this objective were the plant height of the plantlets, the leaf surface area, number of leaves, and number of days to full leaf stage. Also, analysis that was done with ANOVA was used to test the mean difference between the tested strains, and t-test was employed also to test the mean difference for these two banana cultivars and media. And in objective number 2, that was also to see the effect of selected AMF on promoting banana growth that was done under field phase. Now the two banana cultivars, when they attained full leaf stage, we are now ready to be transferred for transplanting. The two cultivar that was William and Granite was used. Here we used only one media that performed well under nursery phase, that was the pot media used. Also the 3 AMF strains that were inoculated during the nursery phase were used. The experimental design for field experiment was randomized complete block design. Also, we collected data on plant height, leaf surface area, number of hands, number of fingers, batch weight of the banana plant, and ANOVA was used to test the mean difference, also t-test. Here are the results for objective number 1 that shows that aim at seeing the number of days from planting or from inoculation to full leaf stage of these AMF plants. Looking from the AMF strains, we see that one of the AMF strains performed well. It had few number of days to reach the full leaf stage. That is Rhizophagus interradices. That had only 48 days to full leaf stage, from inoculation to full leaf stage, compared to the other strains and control, control showed longer period to full leaf stage that had 57 days to full leaf stage. So there is a difference of almost 9 days between the inoculated plants to control. What does it imply? This implies that the AMF that were inoculated shows promoted growth, or shows that they had an effect on promoting the growth on these banana plantlets. Thus, it fastened the development of these banana plantlets. Also, when comparing the two varieties that were used, William and Granite, William had a shorter period to full leaf stage compared to Granite. Also, when comparing the growth media, forest soil and cockpit, forest soil that was filled in polypine but performed well compared to the cockpit that were filled in jiffy pallets. So the media difference could be the size of the jiffy that were used was small compared to the size of the polypine bag that filled the forest soil. So it could be the limited space of these cockpit jiffy lead to shortage of this, lead to underperformance of this performance of these strains. And the results for objective number 2, that was under field phase. And in field phase, we had 2 sites, that was Moshi and Arusha. The data collected here were number of fingers, number of hands, and batch weight. These sites had no any significant difference in terms of number of hands and also batch weight. Arusha and Moshi did not show any significance. Also, the variant works here in the field did not show any significance. But when we compare the strains in the field phase, we see that Rhizophagus interradices that performed well in the nursery phase also showed the positive results in the field phase, as it has a significant difference in number of fingers, also in batch weight. when you compare here in terms of these strains, Rhizophagus claras, that is one of the strains, did not perform well compared to other strains. Here, control had more number of fingers compared to the Rhizophagus claras. Also, when you compare the Rhizophagus claras and the control showed higher number compared to this strain, but the overall result in these strains, Nm-Aist performed well compared to control. The findings of this study showed that the symbiotic relationship that is established by the AMF and banana promotes growth and productivity of banana trees. We see that the number of days to foliage stage that was considered as mature stage for the plant to be transferred to the field was reduced. That was the good news for, especially to tissue culture nurseries, that are preparing the plantlets for commercial. The number of them to stay with plantlets is being reduced. That is a good information for them, as the production cost, the management cost is being lowered. Also, in field phase, we see that the Rhizophagus Nm-Aist had a good number of fingers, also a good number of batch weight and hands. So it promoted its growth compared to control. So this association provides an opportunity to improve agricultural practices and increase banana resilience to environmental stress, as we have seen that climate change, especially drought, hinders the crop production. Also, this boosts food security. Since there is high production or there is increase in yield production of banana, therefore we'll be able to combat the food security aspect. So to optimize the use of AMF, that is a bicycle mycorrhiza fungi in banana cultivation, it is recommended to develop AMF strains that are native to specific conditions, as we use the AMF from Belgium. This could be one maybe of the reason not to perform, maybe one of the reasons not to show more promising results to this, to the plantlets, because in the soil, in the native soil, there are also some microorganisms that are present. So it could be there's a competition between the exotic AMF to the natural occurring microorganism. So it is recommended to develop the AMF strains in the specific environment, as they are seeing that their potential in banana production, and also to conduct extensive field trials across diverse environments. As this study was only done around Kilimanjaro and Arusha, so we should also test its performance in other regions to see how do they behave or how do they perform. And this is the overall process of my research work from the nursery phase.
Okay, thank you, Helena. Thank you, Helena, for your nice presentation. Audience. I've been told that Helena Mieya will be requested by Nyambilila Amori. Nyambilila Amori, are you in the room? Okay, thank you. You come after Justin Mumba. So get prepared, please. So I'm calling Justin Mumba. Please, can you come forward for your presentation? Justin Mumba Justice Mumba is going to present on the local pastoralist knowledge and the practices are key to the success of ticks and tick-borne diseases management technologies applied in the Ngorongoro conservation area. Justice Mumba, please, for 3 minutes.
gears and shift a bit from soil health and talk of ticks and pastoral risks. I'm Justice Momba. I'm from the Laboratory of Host Pathogen Interaction in the Department of Biosystems at the Faculty of Bioscience Engineering at Europe. Closely supervised by Professor Yan, and I have also a number of other supervisors from the Institute of Tropical Medicine and from Tawiri. So I'll be talking of the local pastoralist knowledge and the practices as a key to the success of ticks and tick-borne disease control measures in the reflection of the technologies that are applied to control ticks and tick-borne diseases in the Ngorongoro Conservation Area. So my presentation outlining a brief talk on the biology of ticks, but I'll talk of transhumans and the NCAA proclamation history, and also I'll talk on transhumans and ticks and tick-borne disease control in the NCAA. Then I will give a bit concluding. So ticks and mites, they belong to the order called the Baccaria. Orders for mites, but only one is, and this is the exodid ticks from necrotic or dead tissue materials. And then we distinguish basically two types of ticks. They could be soft ticks that are in the family of Agassidae, and the exhausted ticks or the hard ticks. And these have the scutum and the povil. The scutum is the hard cover. But for the soft ticks from the Agassidae family, from the development, when the eggs are laid through the larvae to the nymph, and finally to the adult, they will only involve one host that is just present, so the tick will not drop from the host when it's feeding. But for the exhausted ticks, the hard ticks, we distinguish three types of those, and this could be a one host tick, meaning that a tick from the egg, when the egg is laid all the way to the adult stage, we just require one tick, we require one host for it to mature. But for the 2 and 3 host ticks, the two require 2 host ticks to develop from the larva and egg before it can drop down and then mount another host to develop into the adult stage. And the 3 hosts will require 3 different hosts. When the larva is dropping down to the nymph, drop down, climb again to the adult, then drop down. So my research is on a 3-host tick transmitted parasite, Theriaria parva. It is transmitted by a brown ear tick, like Spherus appendiculatus. And basically what you see from this slide is that wherever you have protected areas, those are the hotspots of the places where we also have ticks thriving and surviving. And why are ticks important? You can see from this micrograph, the body of the whole animal is covered by ticks, and this doesn't look comfortable for the animal, even to the producers themselves. And these kind of parasites, they are blood sucking, so you have also anemia-related issues. But all the time, if the animal is not treated with the calcites, it will constantly be dancing, restlessness, and they are the poorly performing animals in terms of body weight, and they have poor body conditions. also ticks are vectors to a number of livestock diseases. I'm working on East Coast fever. This is the deadly killer for calves in eastern, central, and southern parts of Africa. But we have also a number of other tick-borne diseases like the corridor disease, that is transferred from a buffalo-derived diphtheria parva to cattle. But we have babesiosis, red water, red urine. We have anaplasmosis, and also we have heart water and a number of other diseases. Heart water is also known as cowdriosis. But there are also vectors for zoonotic diseases, the rickettsia infections, the Q fever, but Lyme borreliosis, quite common in the USA, is transmitted by ticks. But also the Crimean Congo hemorrhagic fever. There is a colleague of ours meeting when I was doing my research in the Ngorongoro is working on this. He's based at the Nelson Mandela Institution of Science and Technology. He's working also on this. So we look at the history of transhumance and the proclamation of NCAA as a conservation area. From the time that we cannot tell it, time immemorial, a disease of wider beast called the malignant cattle fever, ticks and tick-borne diseases, collectively referred by Maasais as indigana. They have regretted the way the Maasais with their cattle traverse landscapes between the highlands and the lowlands of the Ngorongoro and the plains of the Ngorongoro adjoining the Serengeti National Park. And we have information from Western explorers in the 17th century, over 400 years ago. The Maasais have been observed to traverse landscapes between the Ngorongoro highlands and Serengeti lowlands, and that traversion of landscapes was related to diseases from Nm-Aist, the malignant cattle fever, and the tick-borne diseases. And this is a way of mitigating risks. You are looking at the evil, which is the lesser evil you can accommodate today, and let the bad evil go when you are not there. So when you look at the proclamation of NCAA as a conservation area, from when the Germans were here in Tanzania in 1914, they had conserved the Northern Highland Forest Reserve, that's forest that you just encounter when you enter the gate of the Ngorongoro Conservation Area, as a water catchment area. And then the British came in after World War I, and then they had put the Ngorongoro crater as a closed game reserve. They prohibited hunting and the cultivation, but allowed the Maasais to execute their customary rights. But from the 30s to the 40s, then comes this concept of establishing the national parks, setting aside the Serengeti. Then in the 1959 is when the Ngorongoro Conservation Area was set aside, and that was put as a multiple land use area where the integrated wildlife conservation with the rights of keeping from the resident local pastoralists, the Maasais. You look at the establishment of NCA, what you learn from the law that was put, it came with the construction of a number of infrastructures that were important for livestock development, cattle digs and water facilities, but as human doesn't just only rely on cattle. So the gazettement of the Ngorongoro Pastoralist Council in 1996, but also there were one of the notable projects that was in the area was the Eredo Ngorongoro Pastoralist project that started the later phases when they were fading out, they were also involved in policy dialogue. On the tourism side, you can see the NCLA from its establishment had received a number of recognized tourism plans. It's a natural world heritage site since 1979, Man and Biosphere Reserve from 1981. It's a mixed world heritage site in terms of nature and culture. That is from 2009. And the most recent is the UNESCO Global Geopark that was accorded in 2018. So all these tourism plans and marketing or whatever, so the increasing number of tourists that have visited the area. And what you can learn from all this human development, tourism development, that there were expectations that probably we could have pastoralists now settled. And now we have also the Gorongoro as the world-class tourism destination site. But now the question comes in, is pastoralism still driven by transhumans? Or in other words, is transhumans still driving pastoralism? So, I'm doing molecular work studies on my parasite, but I just wanted to understand the influence of pastoralism and tick-borne diseases on the disease I'm studying. And so we had put 242 questionnaires to local pastoralists, and we wanted to know their know-how on tick-borne diseases, the wild animals they encounter when grazing their animals, and which ticks do they kill, the pastures, transhumans, and tick-borne diseases, and also the control options that they have, treatment using antibiotics, and the control by use of acaricides, the chemicals that kill ticks, and through vaccinations. So the results we have, 97.9% of our respondents claim to know tick-borne diseases. But ECF was noted as a more serious disease, this positive fever, and anaplasmosis was noted as a less serious disease. Till to date, transhumans is still the driving force of how pastoralists traverse landscapes from the highlands to the lowlands, and that is regulated with a disease from wildebeest, the malignant cattle fever, and the ticks and tick-borne diseases on the highlands. And respondents, they could tell the wild animals that carry most of the ticks, as usual, the buffaloes and the zebras. And majority of these practice transhumans, and the reasons are still the same. They are looking for salt licks or mineral licks. They are looking for water, better breeding sites, and also for the purpose of change of the environment. And 100% of our respondents use acaricides, and the most commonly used acaricide is Paranex. And this is commonly used during the droughty times of the year, dry seasons, when the mature ticks when they are emerging on the pastures. But they also use cyberdip during the rain season. The most commonly they use the antibiotics, the long-acting ones, and this is because the Maasais are very vigilant. They detect. Okay, I'm summarizing. They detect the parasite in the lymph nodes. They administer the antibiotics, and on the vaccine that we currently have, the infection treatment vaccine, majority of our respondents, 73.6% will use the vaccine. And when they were asked of what they see is important to them, is the availability of extension officers and calcite availability and impotence. From a simple molecular biology kind of work, the disease I'm working on the highlands, because of the control options that the Maasais are using, has reached an endemic instability, and we think the disease transmitted by the Papa is supposed to fever on the highlands is no longer a problem with the Maasais, but rather another tick-borne disease that is called anaplasmosis. And we developed just simple models predicting from what calcites they use, Paranex, and against anaplasmosis, and also the antibiotics that are geared towards treatment of anaplasmosis. They could easily predict the fact that anaplasmosis is now the leading tick-borne disease on the highlands and not the area above. So pastoralists are aware of tick-borne diseases. The way they mitigate the measures is dependent on their knowledge and the way they craft space landscapes, and the use of antibiotics and the vaccinations gives us the story as to why they have been successful in combating East Coast fever. And over time, they can get risks across landscapes between malignant cattle fever and the tick-borne diseases, and they can sustain types of predilection in those parts of the world. And the low detection of the parasites in blood, coupled with the information we get from the authorities, gives you the information that malaria infection is supposed to fever, hemosis. And as I conclude, I say transhumans will remain the main driver of pastoralists as they look on control of tick-borne diseases and ticks when they are applying acaricides and antibiotics. Thanks for listening.
Okay, thank you, Mr. Justice Mugumba, for your presentation. And now I'm calling Nyambilila Amor. Please come and try to stick to time. And Nyambilila is going to present on the land use, land cover change, and oh, sorry. I don't know if you are. Okay, welcome, Nyambilila. I don't have your title here, but you can mention it yourself. Yeah. So you are welcome, and you have 15 minutes, please. Try to be in time.
Good afternoon.
Be within time.
I'm Muri. I'm from Sokoine University of Agriculture, soil scientist by profession and agronomist. I'm here to present a paper titled Building Community Resilience Through Sustainable Landscape Restoration Approach in Tanzania, which is a project-based experience. I'm presenting on behalf of my colleagues. Dr. Mafunda is in the audience, and the others are not here. This is a multidisciplinary implementation project. This is the outline, and I'll quickly go to the introduction of this paper. We are focusing on sustainable landscape restoration approach, which of recent, as you are aware, it has been of growing interest in both research as well as integrated as policy instruments in order to address issues of land degradation as well as environmental management. And in the sustainable landscape restoration approach, it brings together different actors and sectors so as to reconcile the diverse land use needs as well as promoting synergies in the restoration. And this approach is a policy mix, but also help to reduce community vulnerability and enhance adaptive capacity in the face of climate change impact. Just a quick look as to why we are doing this project. As you are all aware, the extent has been of widespread. We are focusing specifically in two river basins, the Great Loire and Lake Rukwa Basin, of which these two have about 6.6 million hectares that has been degraded. And in the sustainable landscape restoration, we are targeting to address the priorities of global environmental facilities, 6 priorities, as well as sustainable development goals 1, 2, 13, and 15, so as to enhance the plan of Tanzania National Development Plan to address these issues of environment degradation. And the photo shows the extent of degradation in the rangeland in Mbarali, which is within the Ruaha River Basin. So to address this project, we first look at the barrier, and we prioritize the barrier that hinders sustainable landscape restoration, which I've listed there. And then we introduced different interventions that will produce outputs such as policy guidelines, joint strategy and planning, capacity building, as well as outreach, and come up also introducing financing of the sustainable landscape restoration. And we also, this output will lead us to immediate outcome as well as impact, which is the overall goal of this implementation of the project. Along the way, throughout the implementation, we have assumptions that all stakeholders will cooperate. We also recognize the risk, natural disaster, as well as political instability, but we also considered integrated or cross-cutting issues such as inclusivity and gender consideration when working with communities. So the objective of sharing this experience with you today is to share what we experience working with community to build their resilience through sustainable landscape restoration approach, and specifically on the policy and institutional framework, as well as the actual sustainable landscape restoration that we chose, practices and technology, and share a little bit of track of the impact that we observed in the period of implementation. So as I introduced, we are working in two river basins, the Great Ruaha as well as Lake Rukwa. We have 7 districts where we are implementing this project and work with 54 villages, and the actual implementation on the ground started in 2022, so this is a 2-year approximately experience. We collected the data through monitoring and evaluation of the project. Prior to that, we did a restoration opportunity assessment methodology as a tool to prioritize first where to do the restoration, but also the kind of technology that will be cost effective. But after that, we engaged in multi-stakeholders to identify different barriers as well as gaps, and also extent of community empowerment as far as sustainable landscape restoration is concerned. Expert observation was also used to collect the information, interviews, focus group discussions, stakeholders workshops were also employed to track outputs and their impact of this intervention. And all the data were collected, as I said, after 2 years. So we deal with policy, forestry resources, climate smart agriculture, income generation as an alternative livelihood, as well as capacity building. Quickly, I'll share key findings of the experience so far. First is on policy. When we did gap analysis of different policies that is needed, we realized that a lot of policies are actually relevant as far as assisting Tanzania to achieve what it has pledged in a bond challenge to restore 5.2 million degraded land. However, we noticed some limitations. The first one is all our policies do not show clearly the mechanism that we can engage other actors in financing. It mostly relied on public financing, but doesn't include a guide for private as well as international partners in our policy. But we also noted that the approach is landscape, but during implementation we were limited with political boundaries. For example, it is one continuous landscape, but we are working on selected districts, so some of the landscape are actually continuous beyond the landscape, the political boundaries of district. Secondly, on the resolution of the gaps that we have observed, first we developed the National Landscape Restoration Strategy. This will complement the National Development Plan, and the strategy is coordinated at Vice President's Office. Secondly, there is also National Environmental Master Plan Strategy and Action, which was revised to specifically include issues of landscape restoration. And then we came up with working groups at the national as well as at landscape and district level, which pull together different experts and sectors to address issues of landscape restoration. On the sustainable landscape restoration practices, what we have done, first we had an intervention of a land use plan. So we took through all the villages where we are working to come up with village landscape land use planning. And so far we have 36 villages that already have their own land use and issued about 4,475 customary certificate of customary rights of occupancy to their land users. And to date, we have managed to allocate land and preserve 28,705 hectares of natural forest that all the villages have agreed they will keep those forests and natural, but also have some places for reforestation where we have achieved 1.6 million trees has been planted. And when we interacted with the communities, they gave us feedback that such an intervention helped to reduce land conflict so far, and also have helped the recovery of the natural forest faster than they would expect, and availability of forest products have increased. Other benefits, including fauna, as well as the sites where the community do their ritual, has been revived. And so it has improved the quality of water also, as well as so this has discourage. So it shows that it discouraged farming into the preserved and conserved land in the area. Still on climate smart agriculture, on livestock, we introduced pasture land, developed pasture land by showing farmers that they can also produce pasture, but we also introduced cattle dips in the villages, cattle crushes and cattle trough to provide service for the livestock. So this service and livestock keepers have showed now readiness to participate in restoration and managing shared facilities such as these facilities that was developed in cost sharing. So they have formed their groups, they manage these facilities and agreed on fees to use and maintain these facilities. In the sustainable landscape restoration, this has shown that it has reduced significantly sedimentation because now they don't have to graze the cattle to water sources such as rivers. And the pasture also have helped them not to graze in forest which is conserved. So there's no need to graze in the forest or reserved area such as close to the water sources. The project also went further and facilitated the communities to have alternative income generation activities. So this was done in groups, farmers groups or community groups with the gender and a special group considered. And some have improved poultry farming, beekeeping, as well as value addition in dairy and production, milk and dairy. So that also have discouraged a lot. Doing other income generating activities that would otherwise destroy the environment. The project improved the access to water by establishing water sources close to the settlement areas, which has reduced a lot degradation because they don't have to go to the river or wetland to fetch water for both human and animal. What have we learned? Key 3 lessons. First, sustainable landscape restoration must be supported by multi-sectoral policies, plans, strategies, and framework from the national all the way to village level. Secondly, community engagement is important. And thirdly, it's important to address the barrier, especially on socio-economic activities, to give an incentive to community to preserve their environment. In conclusion, we can say that collective, multidisciplinary and multi-sectoral approach to landscape that use community-based has shown benefits as far as restoration of degraded land is concerned, but also design of sustainable landscape restoration should consider the need of different stakeholders on the ground, as well as call for financing. We have 2 recommendations at this point. First, we call for a comprehensive study on the incentive and mechanism to attract investment from other stakeholders in sustainable landscape restoration that would be inclusive but cost-effective. And follow up by physical studies to quantify what the communities are seeing on the ground as benefit of sustainable landscape restoration. We thank the financial support from the government of Tanzania, GEF, and UNEP, as well as the district and communities we worked with. Thank you very much.
Okay, thank you, Nigeria. And don't go, please. Now it's time for our questions, interactions. And Dr. Malanya Wanzi, please can you help us to move the mic? for those who have questions. So presenters, please, can you come forward? Those who presented this session, come and take seats in the table. You are 5. So please come and take seats on the table.
Good evening. My question goes to the last presenter. It was about in what ways the integration of indigenous knowledge system with the community, the so-called community landscape restoration projects to build the community resilience in Tanzania based on your project-based experience.
Thank you. Thank you, presenters. Michael to Amuri. I'm interested in understanding further in your work in terms of aspects that were actually considered when you're actually doing your work. For example, how did you integrate issues of biophysical environmental characteristics, issues of terrain, issues of land use, when you are generating these documents and information? But also, you have also talked about the climate smart agriculture trials that you had and you generated data. So I wanted to know whether those were landscape level data set or just site specific data that were actually collected just as one of data. And when you look at, when you just conclude in general at landscape level, do you have scale that you are referring when you talk about landscape level work that you did? Thank you.
Thank you. My question goes to Dr. Nyambidira.
Actually, it is very nice. Tree planting. I needed to know what the tool have you used to get the data of tree which you have planted. You have mentioned that it's almost we needed to know the tool which you have used to measure the tree planting, because most of the farmers have been planting the tree just in numbering, but they don't consider about the mortality rate and the growth of those trees. But also you mentioned a lot of issues, especially the projects. When at the end you said that you need to connect the smaller farmers with carbon credit. So on that one, I see if you put in the grassland, you put livestock, you put the tree planting, climate smart, the cropland, it has different in carbon credit when you scale. So which one are you going to connect your farmers so that they can get the carbon credit? Because I can see that it is maybe I can say too ambitious. We should be maybe focused on one of the projects so that you can, because I have been working on the carbon credit, I see how it's complicated. Thank you.
question go to the guy presenting on tick and tick-borne disease. Specifically, I want to know that what kind of traditional activities do they have to control these tick-borne diseases? Is there any mechanism traditionally that, or indigenous knowledge to control tick-borne diseases? Thank you.
Yeah, thank you very much for a very interesting session. My question goes to Dr. Murray. I just really wanted to know a little bit more detail about what type of climate-smart agricultural practices did you explore? Or did you just implement one lot, or did you look at different types of climate-smart agricultural practice? So yeah, it'd be nice to know a little bit more about what types of interventions you looked at in the sustainable landscape management. Thank you.
So I think now it's time that you can now respond to the questions, and maybe we'll start from this side, and then the other one can follow. So Dr. Nyambulira, please, can you respond to the questions?
Okay, thank you for very good question and very many too. So I will respond quickly, and if my colleague has something to add, I would request maybe will contribute. The first question is on indigenous knowledge. How was it integrated in our SLR? On this, because we are working with communities, there are some technologies that they have been using, so we have we have improved on it. For example, on the beekeeping, so they had their own way, their own beehives to keep the bees. So what we did, we increases the number as well as different types of hives on that. So that is one example. But there are also others that we have integrated, because before we do the intervention, we had agreed on what they know and what can be best as far as resilience to climate is concerned. The second is what aspect we consider in terms of biophysical characteristics of where we worked. Yes, we looked at the biophysical as it is, and that's why we had also an intervention of land use depending on the physical characteristic of the area. So in areas where there is the mountainous and the slope is steep, so those areas were allocated for conservation in forests, natural or planted forests. In the lowland, where the rice thrives well, it was allocated for farming. And in other intermediate for upland crops such as maize and sorghum was considered, as well as settlement areas. So that is how we considered the biophysical. In terms of characterizing them, that is what we said is the recommendation for continuation of what we are doing after this qualitative data. Climate smart agriculture trials I presented were they landscape level or site specific. Those were site specific because we were doing scaling up. So we were implementing specific climate smart agriculture for specific environment and community. So what I presented is site specific. The scale of landscape, as far as this intervention is concerned, is basin. Great Ruaha and Lake Rukwa Basin. That is how we characterize the landscape. Tools to get data on tree planting versus mortality rate. Yes, like I said, we were using project monitoring and evaluation. So there were more than 1.6 trees were planted, but when we monitor, we noted that 1.6 are actually surviving. So we didn't, these were not like were planted without considering mortality. So that was taken care of, and actually we planted a lot more than 1.6. Carbon credit. Are we too ambitious? We have so many interventions. We get feedback of being too ambitious, but in terms of coverage of the area that we are working with. But as far as carbon credit is concerned, we have only chosen one, that is natural forest. Those are the ones that we are going to build up and register for carbon credit. Even the planted trees, we haven't considered registering for carbon credit at the moment. So we choose the natural forest. And actually, in one of the areas, we have a success story. One of the neighboring village is already participating in the carbon credit. So others are also, they are anxious to participate too. Type of climate smart agriculture, they are diverse. For example, in rice, we are using system rice intensification, a little bit slower flooding, and good agronomic practices. In maize, we are using conservation agriculture, intercropping, conservation tillage, intercropping with legumes. In terms of varieties, we use, depending on the climate, we are using the drought tolerant like sorghum, as well as early maturing varieties. So we have packaged it in that way, depending on the area. For the livestock too, access to trough and deep, we consider it as one of the climate smart agriculture that will boost the productivity and reduce vulnerability to climate, as well as introduction of grasses for pasture that are drought tolerant. Thank you.
Thank you, Dr. Mori. Because of time, because of time, I think let us end with Mr. Justice.
Traditional methods used by pastoralists to control ticks. The kind of breeds they keep is an indigenous type of cattle breeds. There is the African short-horn zip that is quite resistant to ticks and tick-borne diseases. But they also practice burning of grasslands during the times of drought in dry seasons. But the movement along landscapes between the highlands and the lowlands that I've talked about is all about looking at which risks can you carry. So they get to the highlands because the malignant catarrh fever from wildebeest in the lowlands is more serious, but they can tolerate the infection of ticks on the highlands that will lead into East Coast fever and anaplasmosis. But when the wildebeest are gone from the lowlands, then they can go back into the lowlands. They know the migration of wildebeest has zebras in it, has gazelles in it, and through that mode of grazing succession, when the zebras are picking up grasses, they also pick ticks, followed by wildebeest, which are quite a number in terms of millions, a million or so. When they graze, they also pick ticks, and finally of the gazelles, they also pick ticks. So once all those have gone, the land has been slashed, quite a number of ticks have been picked out, and now cattle are in the lowlands, which has a substantial amount of ticks, and then they can comfortably graze there, but they will still apply some acaricides. I talked of cyberdip, that is famously used during the drought season because it responds better to the immature stages of the ticks during the drought season. But the movement, as I talked about, of the wildebeest during migration also picks quite a lot of ticks from the grasslands, and this is well known by the Maasais themselves. When they are gone, they know the kind of ticks that are there and the kind of acaricide that they have to take. And it has been a practice of a number of years, and it has now been like a tool that has been adopted as part of how they mitigate risks of ticks and tick-borne diseases across the districts. Thank you.
Okay, thank you, Mr. Justice Mwomba. And I think we had the questions to only these two presenters. And yeah, I think now I will welcome my colleague, Dr. Akida, to continue with the rest of the session. For other presenters, please, thank you again, you four presenters, and you can go back and take your seat.
Thank you very much.
Welcome, Akida.
Dr. Godian Matama and the team. Makofi zaidi. Going to the podium is Dr. Akida, who is taking us through the second round of this session.
Thank you very much, MC. Now I would like to invite Mr. Malco Karibu. So Malco will be presenting his research findings on screening of maize. Karibu.
Asante. Good afternoon to you all. My name is Marco Mwendo. I'm a PhD candidate at Nelson Mandela, pursuing sustainable agriculture, specializing in plant molecular breeding. I'm going to present to you some of the findings from my PhD research in terms of screening of maize genotypes resistant to Aspergillus flavus infection and contamination in agroecologies of Tanzania. I'm going to take you through this outline from introduction to conclusion. As we all know that maize is a staple food crop in Tanzania, grown almost in each agroecology due to its adaptability potential. And in Tanzania we have 7 agroecology ozone with the different potentials and challenges to attain agricultural sustainability. And these agroecologies, we have coastal and semi-arid plateau, southern and western highland, northern highland, and other. And each agroecological zone has unique climate, soil, and vegetation. They support a wide variety of crop, and they play a vital role in the economy of Tanzania. From here you can see types of cropping system in Tanzania. We have monoculture, we have intercropping, crop rotation, strip cropping, multiple cropping. In all these cropping systems, we found that maize is a crop that is being cultivated. And from this map of Tanzania, we can see maize is almost grown in every part of the country. And in 2022 data, the area cultivated was 4.4 million hectares, with the production of about 5.9 million tons, and therefore the productivity was 1.48 tons per hectare. Maize belongs to grass family. It has 10 chromosomes. It's a cross-pollinated crop, and a genome size of 2.3 megabytes. And it is believed to be originated from Central America and introduced to Africa by Portuguese. The crop has several importance. It's used as food, also livestock feed, but it's a source of protein, calories, vitamins, and minerals, but it's also a component for different industrial products like starch, glucose, dextrose, but also it's a source of income to farmers. As you have seen, the productivity was 1.48 tons per hectare, but the potential is about 6 to 11 tons per hectare. But in America, it goes up to 25 tons per hectare, and China 22 tons per hectare. But for us, it's still low, and we have several production constraints. This includes low soil fertility, drought, we have soil acidity, pest and diseases, and in addition to that, we have post-harvest losses due to fungal infestation. And from this table, we can see the maize production and export. In 2022, it was 5,011 tons export quantity with export value of $88,000. But in 2022 was export value was about $91,000. So you can see it's very important for country economy. And from this table, we can see the prevalence of aflatoxin in across different zones in Tanzania. We have zones, we have the region, and samples exceed maximum limit of 10 parts per billion for total aflatoxin. And we can see in Morogoro, it was almost 43%, and in Geita, 40%, Tabora to 30%, but almost in every zone. Maize is most important crop grown and consumed in Tanzania, almost 240 grams per day per person. And the mostly cultivated maize in Tanzania, they are susceptible to Aspergillus virus. And the study conducted by researcher Bon in 10 district, the sample found it was having 12 to 162 parts per billion. As you can see, it has exceeded the tolerable limit of 10 parts per billion in East Africa and Tanzania. And due to this, the estimated probable daily intake of aflatoxin E1 ranged from 151 to 272 nanogram per kg all the way to a day. So it's a serious problem. And in 2016, 2 regions in Tanzania reported 68 cases, and 20 deaths due to consumption of aflatoxin infected maize. This problem affects consumption and exportation of maize, and it has been a challenging problem to mitigate by different methods. Management through cultural practices has been employed but with limited effect. And from this, you can see the life cycle of Aspergillus virus in the field. They can overwinter through kernel, crops, and debris, but after mycelium respiration, it can be transported through winds and insects, and under favorable temperature and moisture, they can infect the maize. But also here you can see, I've just given you an example of few crops, but the problem is in a wide range of crops. But here I'm going to talk on groundnuts, maize, and coffee. And the aflatoxin production can happen pre-harvest or post-harvest. And during pre-harvest, we have external factor, also environmental factor. External factor, we have like birds and insects, they can damage the seeds. But the environmental factor, we have high humidity, we have temperature, also drought. All these can influence the Aspergillus species contamination. But post-harvest, during transportation, during hulling, also they can damage the crop. Also during storage under high humidity, temperature, and insect also, they can contaminate, they can facilitate contamination with the Aspergillus virus. And all this at the end, they cause aflatoxin contamination, and the end results, it can affect the human health and the nutritional value of the crop, but also it's a problem to livestock, and we have seen also it can bring the economic loss to our crop. We have different measures that have been applied, like use of non-toxigenic fungicide like aflatoxin. This can reduce the contamination, but there is fear associated for using it. But also it's resource consuming. So due to health problems and loss of income resulting from aflatoxin contamination, there is need of developing aflatoxin-resistant maize varieties to complement the existing mitigation methods. This study aimed at determining the degree of resistance in maize genotypes to maize kernel infection by Aspergillus virus and aflatoxin accumulation. The identifies resistant maize genotypes will be used to improve the working controlled maize varieties in Tanzania. These are the 20 genotypes that I used. Some were taken from Tanzania Agricultural Research Institute. These are resistant varieties, but we also have lines from seeds. experimental design used was a completely randomized design with free application. Then at selection stage, the plant were inoculated with aspergillus on this suspension. And after maturity, the crop were harvested separately and air dried to 14 moisture content. Then the sample were sent to the International Livestock Research Institute for aflatoxin quantification, data analysis using ultra performance liquid chromatography using standard procedures were conducted. And this was the formula used to calculate the total aflatoxin and in all samples. And from this table, we can see the results from my study. Those indicated with red colors from aflatoxin B1 is they are less or equal to 5 parts per billion. And if you go on the right hand side, you can see the total aflatoxin. And those marked with red one, they have less or 10 parts per billion. But from this, all these results, you can see there's a varying degree of aflatoxin concentration. The one with elevated amount indicate that they're susceptible, and the one with low concentration indicates they have some resistance to the disease. And this is just the sample of what I've said. But in this study, we identified 9 genotypes that will be later verified using molecular markers to find if they possess gene of resistance. Thereafter, they will be recommended as a donor parents in breeding program. But also they can be tested in different environments for yield and other agronomic traits. Later, they can be released as new varieties. To conclude, breeding for resistance is the most effective method for using aflatoxin buildup in maize. And this week, work we found 9 maize genotypes that indicate having aflatoxin infection resistance. Integrating resistant maize genotypes into agroecology farming will enhance food security by increasing availability of safety of maize, but will promote good health and well-being by consuming safe food. We reduce poverty by improving farmers' income. Also, we promote sustainable agriculture practices by reducing chemical inputs and food wastage. This will help achieve several sustainable development goals. That's 1, 2, 3, and 12. Thank you for listening.
Thank you very much, Marco. A nice presentation. Dear audience, can you please clap hands again for him? Now I would like to invite Madam Maria Chantal. So Maria will be sharing with us the findings on situational analysis of Nyamagana's socio-ecological landscape in the Cibitoke province of Burundi. Karibu, madam.
Good afternoon, everybody. I am Marie Chantal Ningire. I am from Burundi Agricultural Research Institute. I'm leading the Natural Resource Management Program, and my field is integrated soil fertility management. I was backstopped by Kai Reven. I did my PhD in Kai Reven, and I'm so happy to see Prof. Robson here. Was part of my jury. Okay, regarding this study, this paper, I bring you to the context. In Burundi, productive landscapes are often influenced by a combination of socioeconomic, environmental, and institutional factors. Unsustainable land use practices contribute to ongoing land degradation, manifested in diminished soil health and nutrient status. Over the years, soil erosion has significantly increased, leading to adverse environmental effects resulting in overall decline in crop yield and the loss of biodiversity. We have also anthropogenic climate change, natural factors such as climate variability, extreme weather events, and wildfire. Recognizing the significance of ecosystem services, and they score a growing need for approaches that address the complex challenges in managing socio-ecological landscape. The main objective for this study, the main one was to assess the status and the trend of natural resources and ecosystem services while considering the possible impact on human well-being and the institutional responsive. We had 3 specific objectives: assessing the drivers, dynamic pressures, landscape status, the impact, and what could be the alternative response in the Sub-Nyamagana watershed. Examine the dynamics of the state of the socio-ecological landscape, and then explore the impact of the landscape transition on human well-being, biodiversity, and the ecosystem services. Regarding the methodology, for people who knows Burundi, we say, why did you choose that Nyamagana watershed? This work was funded by International Water Management Institute, one of the CGs, you know. And then they were looking, they were willing to work in the ESC, especially on the Ruzizi plain. So we went to find which watershed could be flowing into the Ruzizi River. As you may know, Ruzizi is bordered by a part from Rwanda, Burundi, and the eastern part of the DRC Congo. So we used the structured individual surveys and the focus group discussion to come up with a DPCR. It's a driving force and the dynamic pressures, landscape status, impact, and the response. So we have the map we used to sample. So the Nyamagana is located in the Imbo Plain and operating along the Ruzizi River as the shared project site among the 3 countries. The second criteria is the significant competing land uses, activities associated with soil degradation, not only agriculture, but we have also soil mining, as you can see on the picture. The diversity of staple crops planted in the region, the quantity of water provided by the managed Nyamagana River and its uses for irrigation. You will see later throughout the results that they don't have tap water. So whatever they need for water, they will look for irrigation canal. The presence of existing initiatives in the landscape management by different stakeholders in the Nyamagana River. So you can see from the left, it's a map of Africa. From Africa, you can see in the middle, that point is Burundi. As we say, it's a kind of part of Africa, like Tanzania, but Tanzania is too big. So through this Nyamagana is located in northwest part of Burundi, in Chibitoke province for those who knows. And we can see in upstream we have dominance of forest, you have the green color, and downstream we have agricultural land and urban areas. And the soil mining is permanent in downstream, and they don't have also enough water. This is geology, hydrology. Yeah, regarding the conceptual framework of the DPCR, based on these driving forces, dynamic pressure, landscape status, impact, and the responsive. We come up through the focus group discussion to have our own data using this method. So the main drivers, it's a whole list. Yeah, mainly topography, agricultural land expansion, and controlled irrigated rice farming. We have the population pressure, etc. Regarding the dynamic pressures, we have unsustainable agricultural practices, overexploitation of natural and artificial resources. We still have bushfires. We have planting eucalyptus, using of chemical pesticides and fertilizers. Regarding the landscape status, what will come out? We have soil microorganism depletion, soil erosion increase, soil fertility depletion, land scarcity, and so on. The impact is mainly land degradation. We have also low groundwater level, low crop and production, productivity, and increasing food production we see throughout the other results, current results. Then we come up to the prioritization. The farmers were giving us the whole list, but what we come up to prioritize was the water harvesting, as they don't have enough water, support the effort at the local government. 2 minutes. Okay. We have also the drivers and defining the landscape in the Yamagana sample watershed. We can see that high population density. Per household, we have like 5 to 7 members. When we come up to the map for food shortage, we can see like 80%, 80 to 90%, they have food shortage for at least 3 months. And especially from July to December, when they harvest, they rapidly bring the production to the market because they don't have a diversity of income. Regarding the land tenure system accounting in the Yamagana sub-watershed, mostly they are using their own family, their own farm. The main challenges we have overexploitation of the mapping of cropping land, extension of almost forest species, soil fertility depletion. For water source, they rely on irrigation canal, but still it's not sufficient. You can see it's only 11. The major activities is a small trade. They try to see how they can feed their family. Soil fertility is low to medium. Fertilizers and pesticides, the level of adoption is still low. Regarding the crop diversity, crop production, mostly the rice is providing enough means for most of the farmers, followed by tomato and sweet potato. For subsistence, it's beans and maize. We have, regarding the impact of landscape transitions, we have soil erosion on steep slopes and unsustainable agricultural practices. So this study brought light of a number of urgent issues affecting the ecosystems, the unsustainable exploitation of natural resources and ecosystem services. Regarding we have also low institutional capacity, insufficient human and financial capital, and limited access to information on natural resources for the appropriate planning and assessment, monitoring, and the practical ecosystem. We have several recommendations, building human capacity, preserve ecosystem, and enhance the standard of living for residents of the Nyamagana landscape, encourage investment in the landscape, promote top-down decision-making when addressing landscape challenges. We need also strict procedure relating to the management of mining sites. I can acknowledge the government of Burundi and also the Belgian Technical Cooperation and the International Water Management. Thank you.
Thank you very much, Madam, for a nice presentation. Can we once again while she's going back? Now I'd like to invite Happiness Mpanda. And Happiness will be sharing with us research findings on the suitability of growth media in screening of resistance to Rhodophyllus similis in banana. Karibu sana.
Thank you. Good afternoon, everybody. My name is Happiness Jackson. I'm working with the IITA, but also a student from Nelson Mandela African Institution of Science and Technology. I'll be presenting to you the improvement of banana breeding via having the precisely and accurate protocol on screening banana lining against nematode resistance. Banana crop has social and economic impact worldwide, including food, diet, and income. Globally, Tanzania is the 9th banana producer, but the 2nd in East African region. Despite the importance of banana production being the staple food, it has been constrained with several pests and diseases, including plant parasitic nematode, Fusarium wilt, black sigatoka, and currently bunch top virus. This burrowing nematode, which is Rhodophyllus similis, penetrates into the banana roots, and then through its migration, it causes the lesion, which cause the rooting of the banana roots, and finally the banana being topped. This is a most way of which we lose the banana yield. Several management practices have been put to ensure the management of this parasite. This includes the use of clean planting material, the use of botanical, the use of biocontrol, but also the use of Nm-Aist and the use of host resistance. The use of Nm-Aist has become, it brings the drawback to the applicator, but also to the environment which it is discouraged to use. But the use of host resistance is the most reliable strategy to manage nematode infection. To have the host resistance, we need to have screened source of resistance, but also the new developed hybrid should be screened to see their status against nematode infection. To have this material or to screen this banana line for the identification of new source of resistance and the resistant hybrid, there is an inconsistency result of that planting material due to standardized screening protocol and inappropriate media for the screening activities. Forest soil has been used as a media to screening nematode resistance, but it has a fine texture which inhibits nematode activity to infecting the banana root. So that we needed to have proper media which will be used for screening in order to get reliable results against the planting material. By knowing that, we have been able to evaluate two media in reference to autoclaved forest soil, which are cocoa peat plug and river sand. But then we used two cultivars which are resistant and susceptible, respectively, to nematode resistance, which are Ngambi kilometer 5 and cultivar run 9. But also we used the two levels of nematode inoculum to identify which would be the best inoculum for the screening purpose. This is forest soil, as you can see from the picture, and the second one is a river sand, and the last one is a cocoa peat plug. To achieve this stage, banana plants were developed from the tissue culture at Arusha, Tanzania, and 144 banana plants, including two cultivars that have been mentioned before, has been used to screen the media respectively. And this media, when they are in the tissue culture at rooting stage, they are goes out to the nursery and they stay there at humidity chamber for 4 weeks before screening. After that, the banana plant has been transplanted into the respective media which we are used to screen for, which are forest soil, river sand, and cocoa peat plug. And then the banana plant has been transferred to glasshouse where the screening has taken place. And here the banana plant were allowed to stay for 1 week more, and then inoculated with a number of nematodes which are 500 and 1,000 respectively. And also, before termination, the plants were allowed to stay into the glass house while inoculated. In 2 weeks, then the half the banana plants were terminated and assessed for nematode penetration, while the half of the remaining plants were stayed for 2 months and then terminated and assessed for nematode reproduction. Nm-Aist model were used to test the factor effect, while the facial protected were used to test the mean comparison. The results showed that below the ground biomass was higher into the autoclaved forest soil, followed by cocoa peat plug and river sand. But here we see there is a difference between the cultivar, which are cultivar Grand 9 and cultivar Ngambi. As I said, they are resistant and susceptible cultivar respectively to nematode infection. And then we saw that below the ground biomass were higher to the Ngambi kilometer 5 and lower to the cultivar Grand 9, because the cultivar Grand 9 are susceptible to nematode infection, and when the nematode infects the banana, it tends to lose the root weight. Also, after 2 months post-nematode inoculation, the autoclaved forest soil has higher planting biomasses compared to the other media that has been used, but also the cultivar Ngambi has higher planting biomasses compared to cultivar Grand 9. That's due to the reason that I have been addressed before. Nematode penetration after 2 weeks post-nematode inoculation were higher in the river sand compared to the cocoa peat plug and in the autoclaved forest soil, whereby we see that there is a difference, significant difference between the cultivar. In cultivar Grand 9, there is higher nematode that has been penetrated, but also when we use 500 inoculum level, higher number of nematode were able to penetrate compared to when we used 1,000 number of nematode inoculum. From here, we saw that river sand has, there is a distinction, clear distinction between the resistant and the susceptible cultivar. Likewise, 2 months post nematode inoculation, river sand has outstanding, having ability to allow high number of nematode to reproduce within the banana root, while cultivar ground 9 has higher number of nematode reproduction compared to cultivar Ngambi, while at 1,000 nematode inoculum level, we have high number of nematode reproduced within the banana root than when the 500 nematode inoculum was used. You may ask yourself why. That's because at the moment nematode were penetrated at when the 1,000 nematode material under the glass house condition to improve the efficiency of banana breeding program. Thank you very much.
Thank you very much, Madam, for a nice presentation. Can we do the same while she's going back? Yeah, thank you. Now I would like to invite Moses. Is Moses around? Yes, Karim. So Moses is going to share with us the findings on plantain, the fruit crop for smallholder farmers and SME in sub-Saharan Africa and beyond. Karim.
Good afternoon, everyone. I'm Moses Nyine. I come from West Africa, but I'm originally from Uganda. So today I'm going to talk about this very important crop, besides matoka and shari, which is the plantain, as a fruit crop, which is very important for small and medium industry in sub-Saharan Africa. I'm not going to overstate the importance of plantain because it is the next in the banana subgroup, which is actually traded globally compared to Cavendish. So plantain is very important globally, just like Cavendish. And we have a lot of variation in plantain. We have the French type, we have the false horn, and we have the corn plantain. The main distinction between plantain and other bananas is that it has a very firm texture even when it is ripe. And because of this, we can generate so many diverse products from plantain. And this is where the small and medium enterprises come in. So how do the farmers get linked to the consumers? The bridge between the farmers and the consumers are actually the small and medium enterprises. And this can play at different levels, at restaurant levels, roadside snack sellers, like those who sell gonja on the roadsides, and those who prepare chips and flour. So despite the importance of plantains, they are constrained by a number of production constraints, including pesticide diseases that have already been mentioned. But one other important aspect is that plantain has a very weak root system, so it is very susceptible to lodging. Whenever you have a big windstorm, all your plantation is gone. So that is another big factor, in addition to drought stress, nutrient stress, and others. And most importantly, the availability of clean planting materials. This creates a very big gap when it comes to the actual production and the potential of the banana production. So, what is plantain breeding in West Africa? When you look at the breeding programs of IITA, the plantain breeding program is actually the first breeding program that was started in IITA to address these production constraints in banana. And because of the success of this program in West Africa, the East African group in Uganda, together with the National Agricultural Research Organization, they said, let us bring this technology for matoke breeding. And in 1994, the matoke breeding program was started in Uganda. And then later on, in 2012, the idea of breeding or improving moshari started. But the actual realization, as mentioned by Alan, started when the breeding program moved to Nm-Aist in 2015. So we interact as the three breeding programs and also interact with the national partners, as you can see in this diagram. And as such, we are exchanging ideas to make sure that we exchange germplasm, exchange ideas to make better varieties for our farmers. The initial concept of breeding was focused on addressing the problem of black sigatoka, which originated in the valley of the Sigatoka Valley in Fiji. So during that time, they identified plantain landraces that had residual fertility, and they crossed them with resistant wild-type Calcutta 4. And this resulted into the 4X plants, or the tetraplays, that were crossed with improved diploids to generate plantain hybrids that were registered as pitas, or plantain from IITA hybrids. This, to date, we have about 23 hybrids that are existing, and these surely have good agronomic characteristics and black sigatoka resistance or tolerance, but they vary in terms of quality, so we still have to do a lot on this. The next graph that you're seeing is telling you the time scale that it has taken for some of these varieties to reach the farmers. For example, Peter 3 was in 2016 registered and raised in Ivory Coast, and in 2018 some of the Peters were registered in Cameroon. Some of them are being evaluated in India, like Peter 16, and they'll be released in 2025. The bubble that you're seeing in between there was a growth time when plantain breeding was flourishing. Then all of a sudden, there was limited funding, and now we are at the trajectory where we want to push again the plantain breeding program to the level where it deserves to be, focusing on the consumer traits using the target product profiles. So this is being done at the moment, and we hope that in the near future we shall have new, better plantain hybrids. So when you look at the distribution of the Peter hybrids globally, you see that they are present in East Africa, they are present in West African countries, and they have gone beyond. That's why in my title I included the word beyond, because they are being evaluated in India, they have gone to Colombia, Brazil, and the Caribbean. So in the current model, where we are targeting actually the consumer preferences, we are looking at ways of optimizing the breeding scheme, whereby we focus on parental improvement, and then once we have generated good parents, we have a better chance of producing hybrids that will be easily adopted by the farmers. And to do this, we have to factor in the breeder's equation, whereby we are looking at increasing the genetic gain through increasing our selection intensity, through increasing the variability in our breeding program, That's why I've highlighted those two, but also reduce the breeding cycle so that we can deliver the products that the farmers actually like in time. We have one challenge in plantain breeding. One is sterility, and this is a big problem because we are not able to produce many seeds to generate enough hybrids to evaluate. If we can cross that bottleneck, then we can actually improve the genetic gain. Also, embryo abortion, post-pollination, and embryo dormancy are other constraints. So as I have already mentioned, we are now focused on demand-led breeding. So we are working with national partners to make sure that we engage all the stakeholders in defining what kind of products they want us to breed for them. So in West Africa, we have NICOD in Nigeria, CRI in Ghana, University of Kisangani in DRC Congo, and other network members. And we are hoping that in 2025, we are going to have all these partners in form of a network so that we can better collaborate with one another. In East Africa, they have already a network, and we are engaging them. What we are asking them is to generate their target product profiles, and then they can ask materials from IITA plantain breeding program, evaluate based on their target product profile, and then give us feedback so that we can improve on our breeding process. So in summary, we can say that the Peter hybrids that were developed in the 80s and early 90s have good agronomic characteristics which have the potential for the smallholder farmers and also for the medium and small enterprises in terms of value chain addition so that they can increase the income. The current breeding efforts, as I've mentioned, we are actually focusing on the stakeholders so that we can satisfy their needs across the value chain, and also to improve the genetic gain by doing all sorts of things that will actually improve our breeding efficiency. And IITA is championing in this aspect because it is the only plantain breeding program in Africa that is actually assisting the farmers and the small and medium enterprises in this regard. So if you want to access some of these materials, you can request them through IITA Genetic Resource Center. You can reach me, and then I will connect you to this Genetic Resource Center. Through SMTA, you can freely get these materials. Thank you for listening to me, and I wish you a nice conference as we continue along.
Thank you very much, Moses. Thank you very much, Moses. And now, Moses, don't go. Please, have a seat. And then I would like to invite the rest three presenters so that the other presenters, so that we take questions, and then we allow the remaining two to finalize. Two presenters. So when they are coming,
please, MC.
Yes, please.
Any question or contribution from the audience regarding what has been presented? Yeah, maybe the presentations were very clear in a way that each one of us understood. So this way I would like to, please can you go back? I would like to invite.
Thank you. Before you invite them, you invite the next speaker. Can you stand up and we stretch for a minute? You can stretch for a minute. Yeah? At least. While the next speakers are getting ready. Just for 1 minute.
So while we are stretching,
Thank you. Sit down, please.
So Dan is going to present
nematodes. So nematodes are a fairly serious pest of bananas, cause undermining the root system, resulting in toppling of bananas, reduced bunch weight, reduced longevity, etc. And I'm often asked, what kind of damage do they really cause, not just in banana systems, but across the spectrum, because they are underground, out of sight, ignored, if you will, but certainly overlooked. And I've used this example of a root. This is actually a rice root because it's transparent as opposed to a banana root. But if you've got nematodes munching their way through the root system, as these are, migrating up and down, laying eggs and multiplying as the way they are there, obviously it depends on the density of the infection, but you can see that they cause actually a lot of damage to individual roots. And this translates into diseased roots, necrotic roots, and ultimately dead roots. In terms of bananas, that falls back to the seed system, the corm, and it infects the seed itself, which is then less able to perform on the one hand, but also transmits and transfers the disease to the next field. In terms of Africa and African banana systems, we have, give or take, 3 systems: Western and Central African system, the lowlands, the highland bananas in East Africa, and we also have the Nm-Aist in Ethiopia. As you may imagine, or perhaps not, depending on whether you've thought about it, but the nematode community also differs by those systems. And contrary to popular belief that Drophilus similis is the nematode of bananas, there's actually a whole community complex of nematodes that affect bananas. And in West Africa, by and large, Drophilus similis is actually not a major issue. It's others that are, but of course it depends on the individual context and fields, and they are there. East Africa, the Drophilus similis does tend to be the dominant nematode, together with Heliobotulus multicinctus, but again you have got a community, while the Nm-Aist systems in Ethiopia are primarily dominated by Patalanchus goodyeii. And these contribute, of course, to the yield gap for both bananas and for plantain, but of course it's not just nematodes that are part of that yield gap. And in context of soil health, we're looking at soil-borne pests and diseases, and there are others such as bacterial wilt, banana weevils, fusarium wilt, as we've heard earlier on, and of course nematodes. And so what options do we have for the management of these? Well, again, keeping everything in context, nothing happens in isolation, and you have a whole spectrum of pests and diseases that occur on the banana at any given point in time, and rarely individually, if not ever. And of course, plant host resistance is the basis to all good crop pest management systems. Breeding Better Bananas initiative in particular is a very commendable initiative, led by Ronnie, of course, and with Al and everybody else involved in it, a large multi-team with a primary focus on addressing pests and diseases through resistance breeding, for multiple resistance in particular, and we've heard about that from Al earlier on, and the nematode aspect in particular from Happiness, who did a very good job of presentation about Happiness. And of course, combining good genotypes, genetics, with seed sanitation, if you will, or planting material, healthy planting material, there are ways to manage this and promote simple technologies. And I'm looking behind here actually, and the theme is advancing sustainable agriculture together with technologies. And technologies don't always necessarily mean high-flying, blue sky, cutting-edge research. Sometimes the simplest technologies are actually the most fitting, the most suitable, and the most adaptable or adoptable. We don't always have to look for the most technically developed. So simple mechanisms for healthy seed, including micropropagation as well as macropropagation, that's tissue culture, towards getting good, healthy, uniform planting material that is healthy and of a good genetic basis. So soil health. There are a few issues with soil health. One is its definition, and we've got an FAO definition here, which is actually quite succinct, contrary to most of the things that FAO is involved with. But some of the issues are exactly what is soil health, and if I went around the room now and asked each of you what soil health actually means to you, we would probably have a whole spectrum of interpretations of soil health. The other issue is, how do we measure soil health? Well, of course, that may depend on your interpretation of what soil health is, but there's also sort of a myth around what soil health is and how we measure it. And then, of course, the biggest issue is what can we do to improve soil health or maintain soil health, and what technologies do we have, or options, or practices do we have to recommend to farmers to improve soil health, maintain soil health, etc. And so it's not an easy concept, and there's a lot of discussion and differences of opinion around the table, to say the least. Soil health is also not about poor soil health, but also about positive soil health. So it's not just about sick soils or denuded soils, it's about healthy soils that are actually full of life, full of biodiversity, and teeming with biodiversity. And according to this, which I found on the internet, of course, soils have got at least a quarter of the world's biodiversity. So, however, our knowledge of soil, beneficial soil, bioreturn soil health, is literally probably the tip of the iceberg. And if we take that to Africa, it's probably the tip of the iceberg that we actually know and understand about soil health. So yeah, okay, so we do actually need to study it hard. And as I'm a nematologist, just to put it on the table, there are lots of beneficial nematodes that live in the soil as well. I beg your pardon, let me take that back. A lot of people think nematodes are only parasitic to plants or animals. But actually there's a whole host of nematodes in the soil that are actually beneficial. I'll very quickly go through them. We have our bacterial feeders, our fungal feeders, we have our plant parasitic nematodes, as well as predators and omnivores. But we often focus only on the plant parasitic. The reality is actually the plant parasitic nematodes compose about 15% of all the nematodes in the soil, so it's a minor proportion. So in terms of studying the root system, soils on the bananas, and just one example, this was in Uganda, which we had a PhD study looking at the beneficial microorganisms in the soil to look for potential antagonists of nematodes and pests, basically. And from 401 isolates, this is from one field in Uganda, by the way. So we had 401 isolates that we were able to isolate. There's obviously more than that. And of those that we isolated, 37% fusarium species, which 154. And of those fusarium species, and just put this on the table, 37% fusarium oxysporum. And for those that don't know, fusarium oxysporum is the pathogen that causes Panama disease, tropical race 4 and race 1, race 2, etc. It is a pathogen, but it's also not a pathogen. And we've used fusarium oxysporum, it is the most prolific fungal organism in banana systems, basically. Thank you, and as an example. an example from colleagues of mine, Richard Sikora and Luis Sangre from Costa Rica. They had differing results or differing banana production in different fields that have been treated differently in Costa Rica. And I've they colour-coded this actually, and I've using their slides here just as an example. Colour-coded, from those colour codes, there were two, El Real and Maya, that had a very low density of nematodes, Rhodophyllus similis, unlike the others. And when they looked back at this, they looked at the soils and found those two that had low nematode densities were very suppressive and very productive, unlike the rest of them. In isolating organisms from those soils and comparing it with a nematicide control and a non-treated control, morning about mulching and the importance of mulching. This is a trial on plantain in Nigeria, and the forefront is without mulch, and the background is with mulch, both infected with nematodes. Mulch has a massive difference, has a massive implication to nematode damage and by consequence other pests and diseases as well, and again another region. We've done quite a lot of work with using mulch from Tithonian, and again very similar. You get great differences, not just in growth from the nutrition of the mulch, but from the amelioration of the soil itself and the suppression of pests and diseases. If there's a rule of thumb, the more mulch, the better, basically. In terms of soil microorganisms, microantagonists, there's a whole host of in there, the fungal bacteria that can have plant growth effects, suppression, including products, I'm running out of time, so I'm running out. Including products that are actually on the market and traded very quickly, just a demonstration from the screen house, glass house, treated versus untreated. In terms of other aspects, we've got mycorrhizae, which we've heard from Helen earlier on, including endophytes. And what is an endophyte? Endophytes are organisms that can colonize plants without causing a disease or damage or a penalty. Fusarium oxysporum is one of those endophytes that we've been looking at and using that to infect tissue culture material, enhance it, bioenhance it, if you will, which leads to growth promotion without challenge of a pest or a disease. Tracheoderma similarly. Now, in the presence of Rhodophyllus similis or nematodes, we found that with the endophytes, you get great suppression, if not protection, against led to much less damage, larval damage, either internally or externally.
Yes, it should be winded up.
Of the corn. So there are a number of different applications from various different antagonists. How do you deliver it though is a major hurdle and a major obstacle to a large degree. And just recently we've been looking at using a biodegradable matrix made from banana in order to impregnate. First we were looking at pesticides, nematicides, chemical nematicides, but also biological agents as well. So we need to look after our soils and water, because they're a source of life, so I feel safe. And while we head into an era of uncertainty, I would say actually one thing that we are certain about is that if we are going to feed our future, we need to look after our soils and treat it properly. And I do like this little slogan that I've, well, not stolen, but University of Tennessee, and on their hats from the University of Tennessee, it says, "Stop treating our soil like dirt." And I think that's a great way to end it. Thank you very much. So we're running out of time.
Wow, thank you very much, Danny. Thank you very much. And now the last talk, who is coming from Professor John. Yes. So John is going to give us an overview on banana bunch top disease. Karibu.
Well, thanks very much. Danny's correct with a few things I was thinking about. Ronnie did ask me to give a general talk on banana bunchy top virus, so similarly broad chat. I think there are very few pathologists here and the virologists are very thin on the ground, so I won't make it too technical. And also thank all the audience for being here. I know we're late, but not quite as late as I feared we might be halfway through the day. So many thanks for your attendance. Banana bunchy top virus is a huge field, so I'll give a brief overview of many aspects, and I'll focus a little bit more on the spread of the disease and the control. Right, firstly, what are the symptoms? Many of you may not have seen it. I think if you're around in Tanzania, you'll see more of it as time goes by. Bunched plants, bunched leaves, upcurled yellow margins, stunted plants, often dark green streaks on the stems, and some colour bars, little dots and dark green dots and dashes on the leaf when you look at it from the underside. But that doesn't occur, it's diagnostic when it does occur, it doesn't occur in all cultivars. It does in Cavendish, for instance. One of the major symptoms is virtually no fruit production. So 100% infection with banana bunchy top virus in a crop is equivalent to 100% disease loss, yield loss. Losses of 80 to 100% have occurred in many places around the world where the disease has been out of control. In Australia was one example about a century ago now, where we almost lost all our production with 90 to 95% losses. And the photographs on the screen now are just a couple of examples from Australia over the last few decades, where the farmers lost control of the disease despite our control program. He hasn't followed it for bunchy top. They're very small, 20 nanometres in diameter. They're actually the smallest virus particles known of any virus of any organism. You can fit roughly 100,000 across the head of a pin, so they're pretty small. But despite that, they cause a lot of damage for a small pathogen. Disease is spread two main ways, via aphids, aphid vector, predominantly the banana aphid, and in infected planting material. Tissue cultures, people must realise, is just small planting material. If you don't go to specific lengths to eliminate viruses, it's a very good means of spreading viruses. You get rid of most things in tissue culture, but viruses are very persistent. Aphids generally spread the virus at a local level. Aphids have two forms, winged or wingless aphids. Winged aphids are formed when the plants they're living on start to deteriorate, or if conditions get unfavourable and they want to migrate, they'll produce a winged generation. Both forms will transmit the virus, but winged aphids are far more important because they've got the ability to travel quite a bit further. But despite their ability to travel, most aphid spread only occurs within 100 metres or so of the source of infection. So when we get to control, one means of control is just a bit of distance from the sources of infection. Yes, and infected planting materials, the means that the virus spreads long distances. So I think in all cases where it's moved to another country or moved intercontinentally, it's people moving infected planting material. So humans are probably one of the worst vectors of banana bunchy top. Just a close-up of the aphids. They're often hard to find, but they're very secretive aphids. They don't like hot temperatures. Their optimum temperature is about 25 degrees C. So it's surprising that it's a tropical aphid, but they often live under the leaf sheaths in protected areas, even a couple of centimetres below ground level, anywhere where it's a bit humid and a bit protected. But in see a couple of examples there down in the throat of a plant, you get huge numbers at times. And another point is banana aphids are universal. So regardless of whether the bunchy top virus is present, the vector will be present waiting for the virus to appear. Where does it occur? Banana bunchy top was first described from Fiji, like Sigatoka, but both of them not indigenous to Fiji. Bunchy top was probably introduced in Southeast Asia, which is the origin of the whole pathosystem of banana bunchy top, the vector, the host, and the pathogen. It occurs widely, but not everywhere in the tropical and subtropical world, with the huge exception of South America, where it's a major quarantine concern. I don't know how good your eyes are on the map there, but in Africa, first appeared in the Congo Basin, or first recorded in sub-Saharan Africa in the Congo Basin, I think in the 1950s. And it's continuing to spread into West Africa, Benin, Nigeria, 2012-13, Southern Africa, South Africa and Mozambique, 2016, and here, Tanzania and Uganda, 2021. But they'll be historical dates because the virus is always ahead of where it's first described. It takes a little while for people to realise they've got the problem. So it's obviously going to be a little bit more expanded than that even now. Diagnostic assays. We've got many ways of detecting the virus. The viruses are basically DNA encased in a protein coat for protection of the DNA. We have DNA detection methods like PCRs, LAMP assays, combinase polymerase assays, all work very well. No shortage of that sort of assay. Serological assays that detect the virus coat protein. The ELISAs we've developed are very, very good. And, one that I especially like is the lateral flow assay, or RAT, or rapid antigen test, that we've developed with the detection of bunchy top. We've made prototypes in the laboratory and they've been very good in that they detect the virus in sap extract 5 to 10 minutes. And the equipment you need is a plastic bag with buffer in and a pen or something to squash the leaf up. So that's all the technology that's required in the field to use it. And down the bottom right-hand corner is a photo of me in the back of the truck just doing a test in the banana plantation. 3 minutes, right? Okay, I think we're on track. Management methods. Basically quarantine, cultural practices or resistance is what we've got to work with. Quarantine, the very best way of controlling the disease is not to have it. So if we can keep it out, that's great. If the virus is in the area, not moving untested material into a clean, unaffected area is critical, and not moving material out of an affected area is also critical to contain it. With cultural practices, prompt and complete eradication and destruction of infected plants is important. So finding infected plants quickly and getting rid of them totally straight away, and replacing them with healthy planting material. I'll talk more about resistance shortly. The mantra was that there is no resistance to banana bunchy top virus, but we'll talk about that in a minute. And by eradication, this is photographs from Australia, we mean complete eradication, not just cutting down the pseudostems, but digging out the plant, chopping it up and killing it totally. The control can work even in a situation like an African smallholder situation, as long as people are good at identifying the disease and they eradicate plants as quickly as they see them and inspect them maybe the frequency of once a month would be ideal. The graphs up in the left-hand side there are data experiments from Malawi, where at the top you can see that the dotted line is the increase in incidence of punchy top over a 3-year period. The red line at the bottom is a 1% incidence. Down the bottom where this control was practiced, you can see the 1% incidence is right up the top. After 3 years, there's a little bit of virus there, but it is controlled. So it works as long as the whole community participates. Right, now a little bit about resistance. There's a huge variety of responses to different banana cultivars, different genotypes to infection with punchy top virus. There's a tendency for cultivars with a B genome to be less susceptible, but even A genomes, as you can see in this graph, some are very susceptible, like Cavendish cultivars. Some, like Gros Michel, are very tolerant or very difficult to infect with the virus. Let's move quickly. If cultivars are slow to become infected, they're difficult to infect. We've done some computer modelling where disease epidemics can be slowed down enormously by using susceptible cultivars, but ones that are just not as susceptible as the worst. The difference between Gros Michel and Williams, for instance, both AAAs, the epidemic's doubling time for Gros Michel is about 3 times as long as it is with Cavendish. As I said, there was thought to be no resistance to punchy top virus, but we've found that Musa balbisiana, work that my Philippine colleagues have done, shown that a large number, 34 they've used here, accessions of balbisiana have been immune.
Should be one here.
Right, no, I think I've got one slide after this. Yeah. Plants seem to be totally immune to the virus. There have been 60 plants of each accession inoculated, 8 inoculated in the glasshouse, screened multiple times over a 6-month period, planted out in the field in an area with high infection pressure where all the controls are 100% infected, and after 5 years the plants are still uninfected. And this is probably the reason why a lot of bee cultivars are showing some resistance to banana punchy top virus. Just a little bit, just briefly mention transgenic genetic manipulation approaches. It's been done in parallel, but there have been many examples where it seems to be working okay in the glasshouse, but transferring the glasshouse experiments and results to the field have been quite problematic. So at this stage, there's no good field examples of transgenic or genetic manipulation working. And just one last point I mentioned, something Danny mentioned about technology reminded me. You don't need the greatest of new technology to control the disease, because in Australia the infection levels, like I said, were 100 years ago, were 95% or so. The technology they had were looking at using their eyes to look at the symptoms and using a shovel and a cane knife to dig up and cut up the plants, and that resurrected the Australian industry. That was all the technology they had. So it's nice to have technology, but you don't need the latest and greatest all the time. Use what's appropriate. And that's the Nigerian method of controlling that.
Thank you very much. Can we clap hands for him? Yeah. And then, because of time, I'll limit questions to only 2 questions.
1, 2,
4. So let's take 4.
Okay. So can I see the hands again? Have 1 there, 2, 3, 3. Yeah. So this is 1.
Thank you. I have a question regarding the disease suppressive soils. Came quite a lot on disease suppressive media, growing media for potted plants. And we see there's an important relation with soil nutrients, and I wanted to ask if you also find that type of relationship in your research.
Thank you.
I will make use of the opportunity to speak. I will address my question to Danny. Very nice presentation. Next time they should give you a keynote lecture. And I was very happy to see you underline the importance of a high biodiversity to maintain healthy soil quality. So my question is, Ronnie has been referring to, we can learn a lot from the natural situations, from the wild population. So my question is, did anybody ever study the natural nematode community or the soil community structure and see how, for example, natural agents, biological control agents can control the parasitic nematodes, for example? Or do the wild strains also have problems with parasitic nematodes? What can you learn from the natural situation, the wild populations?
Well, I just want to make a kind of statement on the question because I think it's very important. Because we have a large audience here from Tanzania. Bunch talk is a nightmare. It's not a joke. All the rest are problems. And it came into the country a few years ago. We should not underestimate, or you're not going to eat matoke and mshara anymore. John is here for a while. I went with Alan Brown and a few more people to Moshi. People have no single banana plant in the field anymore. No single one. When you talk about Sigatoka or Palm or whatever, you still have, you lose plants. You have low yields. Bunch of is zero. I just want to make it say it's coming. And we have to take action. But
here over 20 years ago. The first meeting I went to was about soil health. And producing a proposal to examine soil health to suppress diseases, soil-borne pest and diseases. We could have that exact same meeting tomorrow because we have progressed undoubtedly, but we're still the tip of the iceberg on what we really know, what the interactions are, how they play out, and how they work out at the end of the day. Just going on the mulching in terms of, plant nutrition has a part to play in how they're affected by pests and diseases, soil-borne pests and diseases and nematodes. Better plant health nematodes have less impact on more healthier plants, basically, better fed plants, and that's where mulch comes in. So mulch does have an impact on the soil itself, the soil biodiversity and soil structure, etc. But it also has an impact on the plant itself, and it's better able to withstand nematode damage. And the picture that we have from the plantain in Nigeria is exactly that. plantain has just been completely destroyed where there's been no mulch. And where there has been mulch, of course there's better nutrition, but there's better soil structure, there's better suppression of the nematodes by natural microorganisms as well. So I don't actually have a specific answer to your question there. This will play out forever and ever, and we could talk about it until the sun comes back up. And it's just gone down, which means it's beer time. So I won't rattle on. Natural suppression. I assume you're talking about sort of natural antagonists to use against nematodes. And there are a number of products on the market that are used. All biological control or biologically based products tend to have limitations in their efficacy, their shelf life, their specificity, but there are some very good products on the market. And we're also looking, you know, we heard from Helen earlier on about mycorrhiza. She was looking at crop production basically and improved growth of plants through inoculation with mycorrhiza. Mycorrhiza are another good example of creating protection against nematodes and other soil-borne pests and diseases. Mycorrhizal plants are much better protected or have much less damage from soil-borne pests and diseases than non-mycorrhizal plants. And that's partly through a number of mechanisms, including induced systemic resistance, and that's where endophytes come in. Mycorrhiza are endophytes because they infect plants without penalty to the crop. And the other endophytes that I was talking about, Trichodermis, Fusariums, Pisomyces, etc., they by and large induce resistance. And we didn't really have time in my talk to talk about Fusarium oxysporum, but actually Fusarium oxysporum is an interesting example. There is a pathogen caused by the species, and then we have lots of different strains or populations or isolates that are not pathogenic. And so if you use them as an endophyte, there's a very similar relationship between a different isolate to the same population that ideally stimulates resistance, immunity, or systemic resistance in the host against the pathogen as well. And so that a lot of work has been done looking at non-pathogenic strains of Fusarium oxysporum. Now the problem is, nobody will buy a product based on an organism that is a quarantinable, severe plant pathogen. And so no public company, private company would sort of invest in a product based upon a product that's based upon a pathogen, if you will. Yeah, a good friend of mine who what is now Biobest actually said, we'll never go near it down. It's a pathogen. And that's the first thing everybody will see. So, yeah, we can talk over a drink or lunch or whatever. And then, yeah, I'm not sure I really understood your question, I'm afraid. It was something about abundance of nematodes, and the greater the abundance, or the greater the density, or the challenge, the greater the damage.
Just the presence or the amount of swamp defines the level of infection.
It's definitely related to the density. So that the higher the density, the greater the damage, basically. And simultaneously, the greater the damage there's an inverse relationship with soil fertility as well, which comes back to nutrients. So the poorer the soil, the greater the damage to the plant per unit nematode. So if you have a nice healthy soil and a healthy crop, 1 nematode per gram of soil, for example, will cause X damage. But 1 nematode per gram of soil in a denuded, unhealthy soil causes a much greater degree of damage. So it's not just density dependent, it comes back to the complexity of the whole system, the soil, plant nutrition, plant health, etc.
Thank you. Thank you, Dan, for your remarks. And then this marks the end of what the task you gave me. So I turn the hands to.
Thank you very much. But I see the hand there. Please say something.
Thank you. I would like you to ask if the society has been alerted in eating maize, which has been affected by molds. What if somebody eats banana nematodes. I say the society have been narrated with eating maize with molds, that there are some toxics which are dangerous to health. What if somebody eat banana fruits with the nematodes? Thank you.
You just better nutrified. more protein. On bananas, the nematodes actually infect the root, so they actually don't affect the fruit, but they're innocuous. So if you did eat roots or tubers, for example, so if you eat potatoes infected with nematodes, it's just more protein.
Thank you very much. Thank you. Thank you.
So let's congratulate them when they are going back to their society.
We will do it in a special way. We will do it in a special way. And I'll show you the way. We will do it in 3 factorials. You know how it goes. 1, 2, 3, 1, 2. But I want to, like, that part should play the first part of the 3 factorial, and you do the second, and they will do the third. Can you try? Slowly. Wait. Let's start. 1, 2, 3. Now, so that's how I want to do that. So 1, 2, 3. This marks the end of day 1, but I have a few announcements to make before we leave. Number 1, we have coffee set behind, like where we took coffee in the morning. So you're all welcome for coffee break. And number 2, I have the papers here. I want to register for those who will be interested to go for excursions. I gave you 2 options. Option number 1 is to visit Mount Meru waterfalls. That costs $30 US. And option number 2 is Monduli Makuni Mtuambu trip. That goes for $50 US. So I have the papers with me here. And if you are interested while we are taking coffee break, you can register your name here. Before we wind up, I'll ask the chairman of the organizing committee, Professor Linus, if you have any announcement to make.
Yeah, thank you so much. I think it has been a long day. Apologies, but because we have many more presentations that we have to make for the next days, and some more are coming. So tomorrow we'll start very early, so 8:30 sharp in the morning, we'll start with the keynote speakers, and then we'll spread up into 2 rooms. One will be this one, and we'll have another parallel room that will be taking place in one of the halls, which is called the Buluti. So I think the other details will take place in the morning. So I wish you the nice evening as you continue enjoying our city, Arusha, the Geneva of Africa. Thank you so much. Stay well, and I'll see you tomorrow. Thank you.
Thank you very much, Professor Nishi, and this marks the end of the day. Tomorrow you will receive more information about how we will handle the double sessions. Thank you. Have a very good evening.